pull this out. Connected it. Sorry. Still nothing, right? Okay. Yeah. Yeah. Holding, right? Yeah. Okay. So I'll start the session. Am I audible to everybody? Okay. So a little bit of introduction on my side. I'm Smith. I got started with crypto around a decade ago in school. I have a background in cybersecurity. Have helped some companies like Telegram, Dapnode, Uber, Ghana with cybersecurity. Got into smart contracts around 2016. Worked with some large exchanges when it comes to wallets, infrastructure, security. Recently, I led investments and technical diligence for a Web3 venture fund. Right now, I'm a security researcher, and I'll be your instructor for this session. So I'll be covering DeFi strategies. Tell me, how many of you have coded in Solidity before? Okay, quite nice. And how many of you know what a DeFi strategy is? Okay. So I'll take a brief example of how strategy works, what a strategy is, and why are there strategies? Why do people pool money for a strategy? So for strategy, we can take a simple example as a bank. So let's say if you have $100, if you have $100, you all deposit the money into a bank, and then bank lends out that money to different borrowers, makes the interest, and gives you your money back. So similarly, there are certain pools, certain farms. So today we'll be taking an example of Silo Finance. So on Silo, Silo is a DeFi protocol. So when you deposit some ETH on Silo, you get yield. So let's say just like you put money into the bank, you put, let's say, $100 into the bank, and you get $3 as yield per year. Similarly, you get yield. But what Silo does is, in order to incentivize people to deposit money into Silo, Silo gives you some governance tokens as free money, as yield or as rewards. So let's assume Silo gives you, when you put in $100, Silo gives you $3 as yield, and it gives you like $7 of its own tokens. So you end up making like $10 in yield at the end of the year. So you make 10% yield at the end of the year. But now the thing is, Silo is giving you its own tokens, and its value may be going up, maybe going down. What if every single day you can go to Silo and say that, okay, you have my $100, you are giving me 7% yield on Silo tokens. How about you give me the yield today? I sell those tokens, I buy dollars and deposit again. So that's what we call auto compounding. Is it clear, or am I going too fast? Yeah? So Silo gives you its native token, and it gives you every minute, like with every block. So whatever interest is accrued. So here in this strategy, we are dealing with WETH strategy. This is the strategy we would be dealing with. So we would be depositing ETH into the strategy. Now, if you look at the strategy, you receive 3% and 10% as APR, and there is a boost APR. So Silo is giving you 4.5% as extra APR, and that's what we're going to do. Like, we will be building a strategy whose sole and when you deposit money into Silo and when you auto compound it, there is some fees associated. So smart contracts are not self-executing. Like, it cannot execute on its own. Somebody has to call the smart contract to execute it. But let's assume you have put in $10, I have put in $10, somebody has put in $10, somebody has put in $100. But in order to auto compound, average cost you pay per transaction is like $20. Now, it wouldn't make sense if you are paying $20 every day, because you have already deposited like $100. So what we are building is, we are building a strategy wherein we can pool everybody's money. Like, if you look at this strategy, here there's 1.88 million deposited by several users. This strategy then takes that money, puts it into Silo, and earns interest on top of it. And whatever Silo tokens that we receive for free, if you look, there's something called as last harvest. So there's a function in the smart contract which we call to harvest our tokens. We ask Silo that, okay, whatever free tokens that you are going to give us right now, we'll sell it, we'll get ETH, and again deposit it again. So we are technically auto compounded it. So that's our goal. So for 1 million, paying $10 or $15 in fees once is not a big deal, right? But if you have deposited $100, you paying $10 every day, you will exhaust your $100 in 10 days. But somebody paying $10 for 1.88 million is still a very small amount, right? So like 45 minutes is quite less to cover entire code of the strategy. So what I'll do is I'll break the strategy down in two parts. One is what we call a vault, and one is what we call a strategy. I'll run by the code, and I'll give you the code in a zip file, because if we go and start deploying right now, 1 hour may not be enough. What say? Like, do you guys want to deploy, or should we go over the code? Sorry? Will we go over the code? Yeah. So we deploy. So there are two parts to this strategy. One is the strategy, and one is the vault. So what I'll do is I'll put this into a zip file and give you guys a link. So you can download it on your computers and browse it. Just give me a minute. The Wi-Fi is acting up a bit. So you guys can open this link, tinyurl.com/ETHDubai. If you want a QR code, maybe to scan. Here's a QR as well. Sorry? It's a zip file. Yeah. Can you lower the voice? So if you're not able to scan it, just type in tinyurl.com/ETHDubai. Were you all able to open it? Okay. So in that, so if you go to Strat, then there's a folder called Contracts, then BIFI, then Strategies, and then Silo, and then Strategy Silo. So you guys got it? Okay. So there are two main smart contracts that we use here. One is called as Strategy, and one is called as Vault. So what we do is basically we take user deposits into Vault. This is the Vault contract. So this is the Vault contract. So this is the Vault contract. So there are some helper variables and functions that we have here. So Beefy, we are using Beefy's Vault. So Beefy is a very famous auto-compounding DApp that a lot of people use to deposit their money, and they automate auto-compounding with that. So with Beefy, what we are doing is we are building a smart contract called as Vault. You can ignore the first variable for right now, strategy candidate. So we declare a variable called strategy, which will hold the address of our smart contract, which is called a strategy, which contains the actual code, which will be a Swiss Army knife, which will take our money, deposit into Silo, auto compound, all that stuff. So this contains some functions. So let's say if a developer makes any changes to this, there should be some delay before the changes go live. So we have something called as approval delay, but we won't get into that. So there's this function called as initialize, which we initially called to deploy our Vault contract. So in that, so our Vault contract is essentially an ERC20 token. So when you deposit money into the bank, okay, you get some receipt, like you have it on your passbook, you have it somewhere. So when you let's say buy government bonds, you deposit money with the government and you get a bond. So here in our Vault contract, we'll be issuing ERC20 tokens for all the people who have deposited money into our vaults. So initially, when let's say somebody deposits $100, we give them 100 tokens. And now nobody else has deposited money into our vault. 100 tokens are out there in the market, but with the yield, our tokens are now 107. So now the 100 tokens that we issued are now equivalent to the actual $107. So that's our strategy here. And then, so we initialize it. We give a name to this ERC20 token. We can give it maybe name as Beefy strategy, Silo strategy, something like that. We give it a symbol. We need to own that contract. So we are using OpenZeppelin. OpenZeppelin are some open source smart contracts that we use so that we don't have to write a lot of code, a lot of redundant code. OpenZeppelin are some open source smart contracts that you can use to deploy ERC20s, ERC721s. So we pass these 4 things while creating a new vault. One is the name of the ERC20 you want, the symbol, the strategy smart contract. So before the vault, we need to deploy a strategy. I'll go to that in a moment. And there is an approval delay. So let's say if a developer makes any changes to the smart contracts, people need to know that, okay, somebody has made a changes. Maybe I want to withdraw my money, something like that. Let's say, so in this smart contract, because we are managing people's money, we have a fee of 5% that we are charging to the users for managing their money. But let's say if tomorrow a developer increases it to like 50%, people may not want to have their money into the vault. So there's something called as approval delay. So let's say if I deploy new strategy today, maybe it goes live 7 days later, not before that. So there are some helper functions that we deploy, which is want. So basically, what is want? Want function returns us the token that we are taking. So in this strategy, uh, we are taking with as the token. So when we call this, it will give us the address of the token. So I have these tokens deployed here. We can call it right now. So when we click on want, it gives us an address. So this is the token that the strategy or the vault wants. We cannot deposit any other token into this apart from the want token. So what is the want token? If we go to ETHScan, check this out. It is actually the wet token, just like we went in the last step. So we define balance. So because we are issuing new shares, new ERC20 tokens, to map it with the money that's in the strategy, we have a balance function. We also have an available function that, like, it is an extra function. We're not using it right now, but it is added just in case we add any new entities to it. So as I said, like, let's say if you deposit $100, so the strategy issues new 100 tokens, which guarantees that you own 100 tokens into the vault. But over time, we are accruing interest. So the $100 you put in is now worth $107. So what we do is we see that how much outstanding amount of tokens do we have in the market and how much do we have in hand. So let's say if we have 100 tokens outstanding in the market and in hand we have 107. So now we proportionally divide it. So each one token is now equal to 1.07. So for that, we have a function to calculate that. We have a function called deposit all, which basically does the same thing as deposit. So this is the function which our users will be calling to put in the money. So what it does is it takes the money from the user and deposit it into strategy. So it calls the strategy and calls a hook called as before deposit. So let's go into the strategy function. So basically, before deposit and after deposit are hooks. Let's say if we want to do certain calculations, let's say if we want to charge, let's say 0.1% on every deposit, maybe we can add a function here, but right now we are not charging anything on the deposits. So the functions are empty. Then we calculate our own balance, Vault smart contract. Then once that is done, Vault smart contract calls something called as earn function. Now, what the earn function does is, here's our earn function. So our earn function takes whatever balance we have. So we have a vault contract wherein we deposit ETH, and then the vault contract takes it to the strategy contract. So for that amount of time, whatever ETH the vault contract has, we check what balance we have. So we check whatever balance we have, then we transfer it to strategy. We use the safe transfer from function and transfer it to strategy. And then we call the function strategy.deposit. Now we go to strategy. When the vault contract calls strategy on the deposit function, like, it takes all the money and deposits into silo, and it emits an event called, whatever amount we have deposited. So our strategy function has, so I've added some comments here. Yeah. So this is our strategy contract. So this is the native address that we use for WETH. Second is the address for Silo token, because the rewards that we receive, right? Silo is giving us some freebie tokens, free rewards, but we need to let the smart contract know what rewards we are receiving. And so we write it down as Silo token. Want is basically the token that we want to deposit. Silo is again the address of the tokens we receive. Collateral is not useful here. Reward claim is basically the addresses we pass to Silo to tell the Silo contract that, okay, I have some rewards and I want those rewards. So we initialize Silo reward addresses. We initialize an helper called as Silo lens. So we can ask Silo, okay, tell me how much money do you have of mine? So because let's say when you deposit into a bank also goes and deposits into some other bank. So basically how the bank will ask the other bank, okay, tell me how much money you have of mine. So this is what Silo lens does here. We use this contract to ask it that tell me how much money you have, how much you owe me, how much rewards you owe me. So have you guys used Balancer or Uniswap? Yeah. So whatever tokens we'll be receiving, whatever the free tokens that we'll be receiving in Silo, we want to convert it instantly because we don't know the price would go up or down. So what we'll be doing is Balancer is similar to Uniswap. So we'll be converting those tokens into ETH instantly. And this is the route we would be using for sapping. So we have some functions. So when we initialize the strategy function, we call initialize. Nothing much happening here. Like you just put in all the values that you pass. Silo address, the contract address wherein you put in money. Collateral token, the token that you want to deposit. So in our case, it will be WETH. So the most important function or the interesting function is deposit. So we see when you call deposit here, when you call deposit here, it calls the earn function. On strategy, it calls deposit. So when it calls deposit, we come here. So then it first checks that, okay, how much ETH do we have? And once you know how much ETH if the balance is more than 0, then we go to Silo. Silo is basically our other bank where we are depositing money, and tell them, okay, here's my balance. Take this, deposit it, and we emit a function that, okay, we have emit an event that, okay, we have deposited this much amount into Silo. Then we again come back here. Our earn function has completed executing. So we again go back here. Now we check that, okay, how much balance do we have now? And let's say so earlier, before this user put in $5, we check what was the balance before and what is the balance after. So let's say if you come in, you put in $100, I issue you 100 ERC20 tokens. So there's a record that you have money into the protocol. Now if somebody else comes in, first we check that before this guy put in money, how much balance did we have? Okay, we had $100. Now he came in, he puts in $5. So we need to issue 5 new tokens, and we issue 5 new tokens to this user. So that's how we come up with a calculation of shares, that what share a particular user holds into the protocol. And then we send them the ERC20s, and we mint some new tokens and send it to the user. So you might say that, like, the money is into Silo, how will it auto compound? So for that, we have something called as the harvest function here. So what the harvest function does, it calls Silo, tells it, okay, whatever free rewards you have accrued till now, give me the free rewards. Yeah. So in harvest function, we claim all the ERC20 free tokens that we have received. So we are also charging some fees to the user. So for all of this, we are charging them 5%. So we do all of that calculation here and fees. So right now we are charging them 5%. So let's say in future we want to charge them 10%. So we have something called as fee category, which is changeable. We can change, add fees. So every time somebody calls the harvest function, we get the fees. Based on that, we swap amounts. We we swap these amounts. We put it into the pool. Whatever extra tokens we receive, we convert it into width, and we put it into the pool. We charge them fees. We emit a function called fees charged, and then we come back to the harvest function. We note down whatever the last harvest time is, because we don't want users to be spending gas fees uselessly calling the harvest function multiple times. So we note down whatever the last harvest time was. Then users can check it, what the last harvest time was, and call the harvest function only if there's a good amount of time. So here, if we see it, it says last harvest was 8 days ago. So that's quite some time. So maybe a user can just go and call the harvest function. But why will somebody call the harvest function, right? So in order to incentivize users to call the harvest function, we give them some incentive. So we can try it out right now. So I'll deploy I'll deploy a fork chain, so we can call the harvest function and see how free tokens we receive. So if you see, I have some ETH, but I have 0 width. So my balance is 0. I have literally no width. Now we'll call the harvest function on the strategy. Okay, so here's our strategy contract. So right now, I have 0 width balance. Now when I call the harvest function on this, you can see I have some extra WETH tokens. Now this is the incentive that we give users on calling the harvest function. We can go over the execution as well in tenderly. So just like how we went over the code, so we first call the harvest function, then we charge them fees, then we lock some profit, we deposit the money again into Silo, and we send some tokens to the user. In this case, I was the user who called the harvest function. I know this would have been too much in like 30 minutes. Like, do you have any questions that I can answer in a simple way? Yeah. Sorry? So in case Silo doesn't give us any free tokens, so she's asking that what, yeah, yeah, yeah. So she's asking, in case, what if Silo doesn't give us any free tokens? So Silo has an incentive right now, but it won't last forever. It will only be for, let's say, next 2, 3, 4 months. So in that case, we have a function to see, okay, if we don't receive any Silo token, so one second. So here we have a balance function. So in case if we receive more than 0, if the free tokens that we receive is more than 0, only then we take the hard step of charging them fees, converting all of that into WETH, depositing it again into Silo, and then issuing new tokens and all that stuff. After some time, Silo might stop giving us incentives. So in that case, the balance will not be more than 0. So this entire function of doing the hard step of charging fees, harvesting would not work.
What is the next block for harvest? Can we check it?
Sorry?
The next harvest time, can we check it? How often?
So you can harvest it. You can harvest it anytime. Like you can. So the thing is, we received some free tokens for harvesting, right? This amount of tokens for harvesting. Now, right now, if I call the harvest again, we called the harvest like 2 minutes back. So in 2 minutes, the rewards accrued may be very, very less. We may end up paying like $10 in gas fees, but the incentive we receive may be just $2. So this is why before calling the harvest function, we can check how much of free rewards have been accrued, and if it is more than the gas fees, only then we call it. You can 2 years back on Polygon, when the Polygon's gas fees is anyways very low. So 2 years back, when the gas fees was very, very low, people were calling harvest functions on multiple strategies like every minute. And they were receiving some free tokens, but the gas fees were so low, so it didn't matter even if they were paying gas fees every single block. The rewards they received were always higher than the gas fees. Anybody else like wants to ask anything?
So the question would be, it's not auto-compounded like in the back end. There's actually a user that has to be incentivized to run it.
Sorry?
Like when you do the compounding, auto-compounding,
Yeah.
there actually has to be a user to actually execute it. It's not done within the team's back end to do so.
Yeah, so we don't actually ask anybody to compound it. So there are MEV bots, so who we pay them some incentive to auto compound it. So right now we received this amount, right? So maybe you can write a bot. So Beefy, you can go to beefy.com. There are multiple strategies here. You can go to all these strategies, take the strategy address, and you can calculate that, okay, in case, you can try with cheaper chains, like they are also on Polygon. So you can go to any of their, so this is a pool on Polygon. What you can do is you can check the strategy contract and see that, okay, it has 238K in rewards. So it was last harvested like 11 hours ago. You can write a simple bot and check that, okay, if I harvest right now, what's the free amount of tokens? What's the incentive that I am getting? So you might get like $2 in incentive. Maybe the gas fees you pay would be $50 or something. So 2 years back, I wrote one simple bot which was doing the same thing. So it made like 10,000 transactions in a month or so, and at the month end, it got like free tokens worth $2,000. So anybody of you can just go to beefy.com, take up the strategy contract. There's a harvest function. See that if you call the harvest function right now, how much are you paying in gas fees and how much free tokens are you receiving? If you receive more tokens, just do it. Like on most strategies, if you look at most strategies, like this strategy. So see, just some time back, somebody called an harvest function. So this was the address who called it, 8557. And you see, this address called 8557 received some free tokens. So they received like 0.075 Matic in free tokens. They paid 0.2 Matic in fees. So the free tokens that they received was less than the fees they paid. So they are in loss. So what you can do is, Beefy has like hundreds of strategies here. Just note down the strategy contracts of all these auto compounding contracts. Write a simple bot. It wouldn't be very long. Write a simple bot. Monitor that, okay, if you, and what you can do is you can sort by TVL. So this pool has 3.7 million. Somebody called and harvest 5 hours ago. Same guy, 557. So in this case, he received 0.12 Matic and he paid 0.16 Matic. So it is very close to the amount of fees that he paid. So sometimes what will happen is you may end up paying less gas fees and make more in free rewards. And not only with Beefy, so you can go through Beefy's documentation, you can go through Yearn's documentation, all these contracts, you can call harvest functions and make free money if you bots on the harvesting part, on the smart contract, on the vault, on the strategy.
Can you change the token, rewarded token?
Sorry?
I mean, like instead of silo, can you change token?
Token, okay. So depends. If we are in Ethereum, okay, so Silo is a market which is giving some boost. Same, we can go to WETH, this pool. Here, there is some So this is a different strategy. When you deposit into this, you receive some vector tokens. So just like how we saw the entire strategy for Silo, same way the strategy would be different for Vector tokens. So same way, if you come across any strategy, so this strategy is very different than what we saw. Technically, it does the same thing. It takes everybody's money, pulls it together just like a bank does, and deposits it into a strategy or a lending pool or DEX. But the calculations, how it issues tokens, it's mostly all same. What it does, so this functions change then. So the harvest function that we made here, that will be different for Vector, but majority of the other functions would stay same. So you can use the same contract, you can just copy paste the same contract, and for Vector, you can write the code again for Vector, you can write the code again for Curve, you can write the code again for Aave. So there's a similar So how many of you have heard about Yearn Finance? Yeah, so Yearn is the one who were the first ones to build such thing. So if you go to V3 vaults, this is a vault on Polygon. Right now it is giving you like 28% in APR. So if you go to their vaults, this is the Aave Lender vault. You can go to the vault contract. And you can read the entire code here, like how they manage the money for Aave. So technically it would all be same, issuing receipt tokens for the money people have deposited, auto compounding it, swapping it again and deposit again. But every protocol is different, just like how every bank is different. So the deposit function and the harvest functions, so this is our harvest function for Silo. And this is a deposit function for Silo. So deposit and harvest functions would change, but other than that, you can reuse like 60 to 70% of the code for any strategy you want. And if you want to code your own strategy, you can try out Yearn Finance. You can go to their docs. So you can go to docs.yearn.fi, check out their vaults, their strategies, and you can deploy your own strategy and maybe charge 5% to everybody who deposits money into your token. And you can also take beefy.app. Here you can go through the strategies, write some bots which harvest the money and get some free tokens. So right now the total TVL is like 265 million. If let's say you are making a historical APR of 10%, if you get like 5% of the 10%, you still make up a good amount of money just by harvesting strategies on Beefy, on Yearn. So on Yearn Finance, there are keepers who do the same thing and who take away the money. On Beefy, people like you and me can call the harvest function and get some free tokens. So with that, if you guys don't have any questions, then I'll end my talk. In case you want the code link, again, I can flash it. It was tinyurl.com/ETHDubai DeFi, in case anybody wants to download it. Okay. So then I'll end my talk. Thanks for coming to the session. Thank you.
Is Alexei here? Alexei?
All right, hey everyone, I'm Alexei. I'm the co-founder of Bob, and I'll be talking about hybrid layer 2s for the few people who are interested. So we've seen an emergence of layer 2s on Ethereum, right? Everybody can spin up using conduits, Caldera. It takes you like 5 minutes and you're good to go. But with the emergence of Bitcoin layer 2s and the last kind of couple of months, we've seen more and more interest of people to go back to Bitcoin. What we want to explore is, okay, is there a way for us to combine the best of both worlds, build something on the intersection of Ethereum and Bitcoin, trying to combine security, but also liquidity, and to explore what the benefits could be. So why even look at Bitcoin, right? Obviously, this is an ETHDubai conference, so why is a guy here on stage talking about BTC? Well, Bitcoin has over 300 million users. It's the most widely adopted digital asset in the world, and if you look outside of our Web3 bubble, it's usually Bitcoin that people actually experiment with. And over the last 10 years, what we experienced is, well, 90% of people get into crypto through Bitcoin, but then they leave and they start building things on Ethereum and L2s and L1s because they cannot do all these cool things on the Bitcoin base layer. And what we want to experiment with and explore if we can do is, well, is there a way for us to create a roll-up ecosystem around Bitcoin that will allow us to bring functionality back to BTC and offer a product that does not require me understanding what Ethereum is and just is much easier to distribute globally, because ultimately, outside of crypto, if people talk about, you know, the price is going up, if they talk about crypto, they always talk about Bitcoin. Now, building a Bitcoin layer 2 is actually quite tricky. There's a reason why none exists today. It's because it's not really possible with the technology we have now, but with the latest innovations on the Bitcoin side, we're actually getting very, very close. But taking a step back, right? I mean, you see a lot of like Bitcoin layer 2s coming out, and we've seen attempts by Rootstock, Stacks, Liquid. But the one thing that people forget is there's like 3 problems. The Bitcoin problem, which is quite tricky. Like, how do I get Bitcoin security? How do I get Bitcoin into my layer 2? Just like Arbitrum has native Ethereum and has Ethereum security. But then there's 2 others. There's the ecosystem problem and there's the liquidity problem. The ecosystem problem means, well, you need to provide users with best-in-class infrastructure and tooling. So we could go and, you know, tell people go use Bitcoin script, but that's not going to work. It's very clunky, it's very limited, and it's just so poorly documented. The funny thing is, what people don't know is actually you can write any program in Bitcoin script. You can do any smart contract. It's universally, you know, compatible. You can build Turing complete things in script. But the size of the Bitcoin transactions and blocks just does not permit that, because script is so basic, you know, instead of using Solidity, using like an almost assembly-like language. So we could tell people, you know, okay, we're going to increase the block size, and now you can use script. People try that. Of course, it doesn't work because it's just hard to use. And then that's where, for example, the EVM obviously has a massive advantage. But then there's the other problem, that's liquidity, right? Bitcoin has a lot of liquidity in the native BTC asset. We've now seen your runes, BRC20s, all these other tokens. But realistically speaking, the actual assets that people want are stable coins, and they just do not exist on the Bitcoin layer. Tron, USDT, Tether, actually started on Bitcoin and then moved away because it was so inefficient. So we could tell people, sure, here's a Bitcoin layer 2, you know, it inherits security, you maybe have some good tooling, maybe even you manage to squeeze the EVM in. But if you have no liquidity, you have nothing else to do with your Bitcoin, nobody's going to use it. And again, we've seen that over and over again. If you launch in isolation, you're going to have a very hard time actually competing with other networks. And so the idea is, well, can we perhaps build something that eventually will be secured by Bitcoin and Ethereum at the same time, integrates with the Bitcoin stack and the technology that we've seen created on Bitcoin for the last 10, 15 years, really Lightning, Nostr, Ordinals, BRCs, Runes, all these new assets that are coming out on the Bitcoin network. And there is a lot of interest. I mean, Franklin Templeton tweeted about Runes and wrote a report about Runes, which is basically the ERC20 version of Bitcoin. So stuff is happening there. But at the same time, we want to bring new developers. We want to allow people to start quickly. You don't want to tell a EVM smart contract developer, well, you know, you have to first learn about what the UTXO is. You have to understand how these things work. There's no tooling, so you have to build your own. So we want to actually embrace the EVM. And for example, this is what we do at Bob. We try to combine Bitcoin with Ethereum. We try to be as compatible as possible with the Ethereum stack. So for example, you take the OP stack, you use the EVM as smart contract layer, and then you start customizing it, and then you start building infrastructure around that in theory can be applied to any other layer too, that Arbitrum or Polygon, but makes this much easier to interface with Bitcoin. So you build things like the Bob SDK, which gives you a few tools. So for example, it gives you a way to read every single Bitcoin transaction from your smart contract. So using something called a Bitcoin-like client, so the same thing that you would have on your phone when you have a Bitcoin wallet, you can build this as a smart contract. So this thing reads every single Bitcoin block header and allows you to check, well, did a certain transaction happen? We can also do things like integrating Bitcoin into MetaMask. We've seen that MetaMask snaps already exist. What we built is a MetaMask snap that also allows you to hold Bitcoin, but also runes, ordinals, BRC20s in your MetaMask wallet. So essentially trying to unify the experience, get Bitcoin holders to start experimenting and actually using this new technology, like things that are new to them. It's very like normal to us to have like EVM smart accounts and DEXs and so on, but that does not exist on Bitcoin. So the goal is, okay, create a unified experience where it's easy for me to get my Bitcoin into the system, and at the same time for an EVM developer to easily deploy products and start making them available to this wide community that is just currently sitting on centralized exchanges and cannot do anything else. Now, the question is, how do we actually go about this? Because as mentioned, Bitcoin layer 2s do not exist yet. And I'm going to walk you through like the steps in terms of technological development that we see happening now over the last couple of months and the next 12 months to really get to a point where we might have optimistic rollups on Bitcoin. So if I were to build this, and that's actually what we're doing on Bob, so of course we're biased, but usually would want to start with an ETH rollup. Why? Because that gives you access to liquidity, it gives you access to native stablecoins, on and off ramps, all these things that matter on the product side that you simply do not have on Bitcoin. But then at the same time, what you want is you want to have things like a Bitcoin-like client and different types of Bitcoin bridges, so WBTC, TBTC, that allow you to get Bitcoin into the system, but you have to make it very easy. So unify the wallet experience, don't send users to 5 different bridge interfaces, have one gateway for people to deploy Bitcoin and then be able to access it in the MetaMask. Ideally even plug in, like Coinbase wallet already supports Bitcoin, and there'll be more and more multi-chain browser wallets that make this available. The cool thing here is, and look, this is a super simple kind of bootstrapping technique. You start as an ETH rollup, but you actually build Bitcoin products. So now you can build things like a peer-to-peer swap. So I can have people swapping ordinals or BRC20s or Bitcoin against any ERC20 asset. And what we can do is we use so-called, again, like clients. So if I want to swap some USDC against your Bitcoin, I would lock up USDC in the smart contract and submit my Bitcoin account. This can be done directly from a MetaMask wallet by now. And then whoever wants to do the trade with me just sends the Bitcoin. And then the smart contract accepts a proof that you actually made a Bitcoin transaction. This can be abstracted away from the user. You can have relay services, user interfaces that just take the proofs from the Bitcoin chain and plug it into the contract. And what happens next is the smart contract verifies that, hey, this is actually a Merkle proof for a block header that I have verified, and I know that this is the longest chain that I've seen. So now here you can have your USDC because you actually completed a Bitcoin transaction. And this actually works in practice, and this is the easiest way for people to actually swap Bitcoin against USDT, USDC, ordinals for Bitcoin, runes for Bitcoin, runes for ERC20s. And the goal here is, well, the Bitcoin community is still rather small, right? And when I talk about Bitcoin community, I'm talking about probably the 500,000 users that are very active in ordinals, runes, trying to build new things, because there's been a paradigm shift. People now are really excited to build on Bitcoin. It's okay again to experiment. But at the same time, we have 30 million MetaMask users that, you know, they have 40 different ETHDubai that all kind of do the same, and they have Bitcoin somewhere on their ledger. And now what we want to allow is to actually, the 30 million MetaMask users to get the Bitcoin into the MetaMask and then start doing stuff with it. So that's easy, right? And then obviously we need to bring in Bitcoin security, because ultimately if we don't have Bitcoin security, it's just another Ethereum layer 2 that, you know, maybe specializes in Bitcoin tooling. And the way we can do this is using something called merged mining. Now, this is a slightly complicated image. I'll walk you through the steps. So normally, a rollup on Ethereum, if we go the optimistic way, works as follows. You have blocks sequenced every 2 seconds. So the sequencer, you know, collects the transactions, builds the block, and then every minute you would post the DA commitments to ETH or somewhere else. Now, what we now do is, before posting the data to Ethereum, we give it to the Bitcoin miners. So the Bitcoin miners run full nodes for the layer 2, validate all the transactions, and if they're valid, they do something called merged mining. Now, merged mining is a very, very old concept. It was invented by Satoshi Nakamoto himself with the vision of doing two things: preventing fragmentation of hash rate across 50 different new chains, where miners would have to choose to mine Bitcoin or something else, and at the same time enable side chains. So the whole vision of Bitcoin and Satoshi himself is actually, well, you know, we will have experimentation. Can we create this in a way that actually also benefits Bitcoin? And I'll explain exactly how it works, but think of it this way. Merge mining is the grandfather of restaking. Bitcoin miners can run Bitcoin mining hardware, they mine Bitcoin, but at the same time, they use the hash rate to also secure the hybrid layer 2. Which means that to now attack the system, you not only need to attack the sequencer and prevent frappers happening on Ethereum, you also have to attack the majority of the Bitcoin miners that are actually participating in this merge mining / Bitcoin restaking protocol. And right now, today, on some altcoins like Rootstock, Namecoin, and so on, we see 60% of the Bitcoin hash rate already doing this. And in fact, because we work with almost all the large mining pools, we'll see this number going up to 80, 90% over the next year, and I'll explain why. Now, briefly, you know, to talk about merge mining, this is a slightly more technical talk here. The way it works on the example of Namecoin, Namecoin was the first altcoin and the first coin to introduce merge mining. It was also the first cross-chain concept ever designed. What Namecoin would do is Namecoin would create its block, which would reference the previous block. It would have like a Coinbase transaction, all the other transactions in there, but it would not yet have its own proof of work. So this is basically the block template. And then the miners would hash this part above that commits to all the Namecoin transactions, but they don't do proof of work over that. They include it as data into the Bitcoin block they're currently mining on. And then when they find a proof of work solution that is suitable and hard enough, they would send this kind of data, this block hash, and the proof that this data is in the Bitcoin block back to the Namecoin network. And then Namecoin full nodes would check, okay, look, we have this Namecoin block, we have this Bitcoin block, and actually they're linked, and now I know that there was proof of work made over Namecoin. Because now if you would want to attack this, you would have to actually do the same proof of work level that Bitcoin is actually doing. And the way it works is you can actually be very variable with the difficulty. So you don't have to wait for 10 minutes for every single block to arrive. You can actually go much, much faster, depending on what your target block time is. There's a limit. You can go as fast as 1 minute without starting to break the consensus, as opposed to proof of stake, where you can go much, much faster than that. So what you have is, if you look at this very kind of simplified graph here, you have the difficulty target for Bitcoin, which is higher than for Namecoin. Namecoin had faster block times. And then you would, every time you'd find a Bitcoin block, it would implicitly be a Namecoin block. But you could find multiple blocks in between a Namecoin that accept the proof of work from Bitcoin, even if you don't actually see a Bitcoin block. Now, this is cool. This is not new. This has existed for over 10 years. Like Rootstock has been doing this. But there's one problem with this design. If you require every single block to have proof of work over it, you actually are limited by the throughput, because you cannot go faster than 30 seconds, probably even 1 minute, without starting to see shallow forks. So where miners find a solution within a short period of time, and then due to latency, they just continue mining, obviously, because they don't want to lose even a nanosecond of mining current of operation. So they just continue mining. The moment they find a block, they fire it out, and they continue mining on their own chain. They don't wait to see if somebody else did something at the same time. And if you go below a certain time limit, there's good academic research that shows you start getting forks, and that destabilizes the network. And that's why for almost all of the merge mine chains today, they have like 1 minute block times, which makes it completely unusable for any modern Web3 or DeFi use cases. So what we can do is we can apply the same hybrid consensus design that we see on ETH rollups to merge mining. So what we would do is, instead of having miners validate every single block and merge mine every single block, what we do is we introduce a sequencer, which, as you can see, is already going in the direction of layer 2s. You have a sequencer that basically optimistically pre-produces the blocks, pre-signs them, and then the miner only merge mines on every 100 blocks. So what happens in practice is the sequencer is constantly collecting transactions, proposing blocks. The miner constantly runs a full node and actually constantly just fetches the latest data. But because the proof of work target is set to have, like that a block happens once per minute, or like a solution is found once per minute, you basically always commit to, let's say, the last 100 blocks. And you basically now have a trilling finality gadget. You pre-produce 100 blocks, you have very fast user experience, you can do DeFi, basically can plug in OP stack or Arbitrum into this, but then every minute you actually get Bitcoin's proof of work over this kind of chain, which gives you the combination of very high security, fork resistance, much faster finalization in practice, but still fast block times. And then if you plug this back in into our hybrid kind of rollup roadmap, what you get is, again, very fast block times. Every minute you get the proof of work. And then on the ETHL1 level, we will modify the contract to actually check if the proof of work has been done. So if there's no proof of work, the day commitment is not accepted. And then you can, of course, balance the security between the sequencers and the miners. You can say, well, okay, there's a maximum timeout of 10 minutes before we stop accepting day commitments. Or you basically allow miners even to fork the chain, which can be implemented. So you could also say that the miners can actually fork out the sequencer if the sequencer is misbehaving. This is a kind of parameter that you need to balance between, do I trust the sequencers more or do I trust the Bitcoin miners more? Arguably, instead of trusting one sequencer, you would rather give miners more power to actually fork out a malicious sequencer that's trying to produce things. But you might not have to do that because obviously on Ethereum you may have fraud proofs. Now the benefit that we get here is A, security. As mentioned, you now need to attack the sequencer, censor fraud proofs on Ethereum, but at the same time, you need to corrupt the majority of the Bitcoin mining power because they actually see what you're doing, and without their sign-off using proof of work, you cannot post it to Ethereum. But they also see that it's happening, so they can also just challenge you on ETH if you're not posting any day commitments. They have all the data. It also gives you economic alignment with Bitcoin. We might not care about this a lot on Ethereum. I personally do care because I think if Bitcoin falls apart, everything else falls apart. And essentially, we had the Bitcoin halving yesterday night. We'll have the next one in 4 years. This one will probably wipe out a few small miners. In 4 years, we might see a wipeout of some of the big ones. And that's actually why almost all the Bitcoin miners that currently are looking into innovation, they actually work with us to do merge mining on this new concept. And then the actually interesting thing for Ethereum, because it's an ETH conference, what this does for the ETH user, it gives you faster withdrawals. Because now instead of waiting for 7 days to receive a challenge, we can actually, after a few minutes, be certain that there is no way that this will fork, because you'd actually have to corrupt the majority of the Bitcoin mining power. So what you're doing basically is you're time-stamping the state of the roll-up to Bitcoin, and that gives you withdrawals back to the ETHL1 within a few minutes. Still too slow for the user, but arguably much better for liquidity bridges that now don't have to wait for 7 days, but that can rotate their liquidity every few minutes. And then last but not least, and I know we're already kind of short on time, so rush over this. This is probably actually the most interesting part of the talk, BitVM. So BitVM, there's been a lot of hype around it. People actually, very few people know what this actually does. It was initially presented as smart contracts on Bitcoin. It's not smart contracts. BitVM is a way to do optimistic execution of programs, arbitrary computation off-chain, and then doing challenges on-chain. And obviously we're at an Ethereum conference. Everybody knows, well, this sounds very familiar. This is like Arbitrum, but on Bitcoin. And that's exactly what BitVM does. So BitVM takes the idea of taking programs off-chain, running it, and this can be an L2, this can be an addition program, like in this case, and then basically only committing a part of the data to Bitcoin, right? Why do we do off-chain computation in Arbitrum? Because it's too expensive to actually do all these things on the ETHL1, so we take the computation off-chain, and then one option is to do ZK proofs, right? But there are some limitations there. The other option is, okay, we take the program, we break it down into its bare components, like here. So for example, you can take any program and you can break it down into NAND gates, because NAND allows you to create any program by chaining them together. And then what you would do on Bitcoin is you would take a Merkle tree, or a so-called taproot tree, and you would basically create a circuit. And you would represent the circuit that basically can be any program. You would place it in a tree. And the cool thing is that the root of this Merkle tree commits to that program. So now if I change any piece of the program, the root will change, and that's the same concept we obviously use with transaction inclusion proofs and so on. Now, the cool thing is, again, similar as Arbitrum, you and I, for example, we will commit to execute a certain program, we will post this hash on chain, we will do a lot of pre-signed transaction, and that's the difference between Arbitrum and Bitcoin. On Bitcoin, we have to work with pre-signing certain transactions. There has to be certain ways of spending this. So how it looks like, let's say we want to build a bridge using BitVM. We have 10 people that we trust, or we have 1,000 people, that's even better. They create a setup. They basically all together have an N of N multisig, where at least one person needs to be honest and burn the key. Because if one person has burned the key, you can no longer spend from that deposit. So that's unspendable. Unless you have a pre-signed transaction. And then you have, let's say, 50 operators that get pre-signed transactions during the setup. And these transactions allow them to withdraw a certain amount from the bridge deposit. But then there's an additional set of pre-signed transaction that allows anyone on Bitcoin to challenge the operator by asking the operator to reveal a certain part of the program, essentially in this tree, and then you can easily prove in Bitcoin script that actually the operator changed a certain part of the program if they get a different result. So if we take a very simple example, let's say we have an addition program, everybody knows 1 + 1 should be 2. If the operator says it's 3, obviously we all off-chain know that that's not correct. So now what we will say is, okay, wait a second, that can't be right, challenge. In an on-chain Bitcoin transaction, and we know that the operator is cheating because the operator announced, hey, I made this computation, I want to withdraw the Bitcoin now as payment, for example. Now what we will do is we will take that transaction and we will challenge it. And then the operator has to respond by revealing part of this tree, and it's actually a bit more complex. There's actually 2 other Merkle trees that you kind of tie together, but simplifying, the operator has to respond by showing a part of his program. And if that part is incorrect, I can slash it. And then there's 2 designs. There's BitVM v1, which uses the same bisection style protocol like Arbitrum, where I will check part 1, part 8, part 4, part 5, and then ultimately by jumping back and forth, I will zero in on the exact place where the operator must have modified the program. Now obviously 99% of the cases, we don't need to do that, because if somebody is misbehaving, they just try to steal. But if they're smart and they try to encode, like change only 1 bit in the program to really change the behavior, if they're really smart about it, we will still find it. And what we will do is we will invalidate the Bitcoin transaction and kick the operator out. And then towards probably 12 months from now on, we actually expect to see first on-chain deployment. This is not going to be easy to use. So this is, if we build a bridge using this design, it will not be something that a user would go and say, hey, like I want to bridge in, bridge out. There's a few limitations, like only fixed deposit sizes. So you can only create like different BitVM setups, or like always 10 Bitcoin, sorry for that. So what you will see is you'll see liquidity style pooled bridges on top of that, and just users swapping in, swapping out. But under the hood, you have this guarantee that you can always exit back to Bitcoin, which is something we've never had before. And the best thing is this does not require a fork. So we don't need to change Bitcoin, and we can get to an optimistic style rollup using this kind of technology. Now, what does this give us in our hybrid roadmap design? Because ultimately we can build this on Bitcoin, but again, we solve the Bitcoin bridge problem, we solve the security problem, but we haven't solved the ecosystem and liquidity problem yet. Because again, I can put this on Bitcoin, but how do I get stable coins in? How do I actually get users? Sure, I can beg USDT and pay them like, what, $50 million currently is the price to get Ether deployed natively. Doesn't really work. So what we would do is we would say, okay, now we move settlement from Ethereum over to Bitcoin. We have the fraud proofs occur on the Bitcoin network instead of Ethereum. Or you can do both, but in our example, let's say we move it to Bitcoin. But if a fraud proof happens on BTC, we will relay it to Ethereum, because the cool thing about Ethereum is, as mentioned, we have things like lag clients. So we can verify Bitcoin transactions, and we can easily check that, hey, somebody triggered a fraud proof on the Bitcoin network. Okay, let's trigger escape hatch or do something on the Ethereum side. And the vision here is a user that's bridging Bitcoin from the BTC network should have the security enforced by Bitcoin. Somebody that's bridging stablecoins, ETH, ERC20s from Ethereum should be able to exit back to Ethereum, and then the fraud-proof escape logic should be enforced by the Ethereum network. And that's exactly what you get here. Of course, you could run fraud proofs here on Ethereum and relay them to Bitcoin, but the problem is that, this BitVM construction, it's not that easy to implement. And given that Ethereum still does not have a proper lag client, right? We know that we need kind of a multi-sig for the sync committee. It's easier to do it vice versa. We move the logic for fraud proofs to Bitcoin, but then we verify it on Ethereum because it's much easier to build a Bitcoin-like line and read state from from Bitcoin on Ethereum than vice versa. And then to make it even easier and more compatible, you can plug in the Bitcoin miners, which you can then use for two things: faster confirmation times and guaranteed data availability, because they have actually seen the data and it's easier to actually make sure you have the data necessary to do fraud proofs. And that basically is how we can create, and that's also what we're building at Bob, a hybrid layer 2 that sits between Bitcoin and Ethereum, can import liquidity from both networks, is secured by both networks, and can access a much broader user base, namely the additional 300 million Bitcoin users and more, given now the spot ETF has been approved, that we see today. So in short, it's a Bitcoin L2, it's an Ethereum L2, it's a hybrid layer 2, and actually we're launching with phase 1 this week. So we're launching with phase 1 as an ETH optimistic rollup with Bitcoin tooling. Merge mining will follow probably towards the fall. We're working with Marathon Digital, Antpool, Bitmain, and I'm also talking with Foundry and F2Pool, almost all the big mining companies, to start offering Bitcoin security to Ethereum rollups. Now, I know we're over time, so I'll pause here. The other design that you probably heard of is Bitcoin staking. You can also try to implement a proof of stake protocol using BTC. You do that using extractable one-time signatures. It's a very technical concept, but think of it, if you sign twice, just like on Ethereum, your Bitcoin is lost. This is also cool. There's a protocol called Babylon that's doing it. There's a few others that are experimenting with this. The difference here is in proof of stake, you have capital costs. So you need to get people to actually stake the Bitcoin, put it at risk. So it's not really restaking. Whereas with merge mining, the miners are already mining. It's much easier to bootstrap. You don't need to ask them to do anything extra. Just like on EigenLayer, you just run an extra node. Yes, you risk that you might actually do something wrong. And that's essentially the balance I need to find here. We cannot replicate EigenLayer one-to-one. You have to pick either you have higher capital costs on Bitcoin and you kind of use a Bitcoin as an asset, as a security model, or you go with merge mining, but then you don't have the slashing component, or you combine them where you say, okay, the sequencers have to stake some Bitcoin to be elected as sequencers, or the miners have to stake some additional Bitcoin to be allowed to merge mine, and then they do merge mining. And if they misbehave, if the miner tries to do something fishy, you not only kind of take away the rewards, you also take away some of their Bitcoin. So that model can also be done. It's still pretty early, but then you can really get to EigenLayer style security where you can run this across multiple different applications and have this additional restaking or merge mining security. With that, thank you so much, and yeah, I'll be around if you have any questions.
Yeah, I think we'll just use this one. We don't need the one on the podium. Should we start? Yeah. Okay. Hey, everybody. My name's Sean. This is Nick and Day1. We're part of the team building something called Project Diamond at Coinbase, actually under Coinbase Asset Management. And so effectively that project is a platform for digitally native assets. So very much in the tokenization space, but focused on regulated institutional activity and building that infrastructure on Open Ethereum and on the Base blockchain in this case. So what we came here to do today was just a very basic kind of 101 workshop on deploying your first app on Base. And so I'll just give it an introduction, and then I think Nick and Day1 are going to walk through the steps to build, well actually you should shift to the next page. This is what we're going to cover. So we'll talk through the components of a smart contract application from soup to nuts. So if anybody, you can follow along, we can kind of walk through the detail. It's going to be a set of smart contracts, or a smart contract, a very simple one. It's going to be the web application itself, so the front end, and then the connective tissue between them. We'll deploy that app live on Base, and we'll show an interaction with it. And then we're going to connect, obviously we'll connect all the pieces together and show you how it operates. And then I think what we can do that's useful here today, hopefully, is we can either take questions, or if there's something that you want to build, we've been building and rebuilding financial applications on top of EVM, code bases, and now on the Base blockchain for years at this point, as well as a bunch of other types of applications. Nick and Day1 have tons of experience. So if there's something you're looking to build or you want to get started on, I think we can do this pretty quickly, and then we're happy to just take questions and to try and offer you guidance or feedback, or even just opinions on how you might want to go about your projects. So hopefully that's useful to everybody. If you want to interrupt us in the middle because something we're doing doesn't make sense or you want more detail, just throw your hand up, and let's keep this as informal as possible, because the idea is just that it's useful to you. Okay, so where do we want to start? Nick, you want to talk about the smart contract?
Sure. So basically what we have here is we thought, how can we create something that people can relate to and that's simple enough that it would be a good presentation for people. So everybody loves kind of meme coins, and we're like, what if we had a coin like DGen, and we wanted to wrap it and then create an app around wrapping a token. So effectively what we have here is we created Super DGen, right? And essentially, I'll just walk you through the code real quick. The constructor is very basic. We take the DGen token and we instantiate an ERC20 type of object inside of our contract. And then we've written two functions, a create, which essentially wraps, and a redeem, which will unwrap the token for you. And it does something very simple. It wraps 10 to 1. And so 10 DGen tokens will give you like one Super DGen token. And so I'll walk you through the code here. So the create Super DGen, essentially what it does is it takes an amount, it does some qualification based on the inputs to make sure that the token is of a sufficient amount and that you've approved the amount of token to the contract. And then it effectively here just deposits the token to the contract and issues you a new contract, or a new token, sorry. And that new token is effectively your wrap token. So now you have, for every 10 Super DGen, or every DGen token, you have one Super DGen token. You can do whatever you like with this token. And then on the flip side of that, people wanting to get out of the wrap token, we've provided a quick function here that allows us to perform the inverse of what we just did in the create, right? Where it checks to make sure that you have the proper balance, and if so, it will burn your Super DGen and issue back your DGen token. So very simple application. The purpose of it is just to provide some kind of context on deploying on Base and providing like an application that we can demonstrate interaction from a front end, from a smart contract, from a Web3 connectivity, and just trying to piece it all together for you guys.
So, okay, if we just pause there, we'll pause at each piece. Like, I don't really have a sense of the audience in terms of the difference in level of expertise where you guys might be in terms of deploying your first token, already being experienced developers. Is there Is there anybody that wants to ask any questions about just a very basic two-function smart contract? How you go about doing this, where you might pull the template from, what any of these lines of code are doing, and how to think about it? Like, just feel free to ask questions if that's helpful. Nothing. Yeah, please. Where would you pull a template from? So, Dylan, can you pull up? You've got Wi-Fi, right? You want to pull up just like the Open Zeppelin template creator? I find this really useful. Just like if you wanted to get an ERC20 template, go to Open Zeppelin, go to, what's it called, the Smart Contract Wizard. Right, so yeah, maybe just show, yeah, like, so here you've got a very basic ERC20, right? And that'll create the token. And so if you want it to be mintable, like Dalen just mind clicking on a couple of the features. So it's gonna add those contract features for you. It's importing the extension, and it's allowing you to mint the token. So you can come in here, and whether it's a ERC20, whether it's an NFT 721, 1155s, other features, it gets you started really quickly, and that's basically the framework that you can use, and then you start adding some custom logic on top of it. I mean, there's lots of other ways to do it too. There are templates all over the place, but this one's just, they've done a really good job. Yeah. Anything else? Because what we're going to do next is we'll move on to just very basic kind of web app code. Like, okay, here we'll stand up a little React app. And then we'll get into how do you connect the two together so that you can have a local running web app and you can deploy some smart contract and then you can interact between the two with a simple application. So if that's cool, we'll move on to the next step then, the front end. Yeah? Okay.
It might be hard to actually type on here and hold it though. Okay. Testing? Okay, awesome. Okay, sweet. So what we're gonna do here is go back to Remix. This is where we can actually easily deploy our contracts. Sorry?
Oh, we can only hear them up here. It's only on the monitor.
Hello? Better now? Okay, sweet. So we're in Remix here. This is where we can easily deploy our contracts. So I've connected up with my Coinbase wallet. I've essentially funded it with some ETH. And we are going to start by going through connecting this wallet. So you would connect the injected provider. We have some ETH in this account. And then what we're doing here is we're actually essentially wrapping the degen token. So we would go through and we would go to anywhere where we can find that address. So CoinMarketCap is a good example. And so we've grabbed the address from here. And this would be part of the constructor. So as we can see, we supply it in the constructor argument. So we'll go through and deploy this right now. It's going to pop up our address, which we can see. It's going to cost about 12 cents to deploy this, which is really cheap nowadays. So that's being deployed. And
just for anybody, if it's really like first time for you, using Remix is the easiest way to get started. It's going to be able to let you compile your code, get errors, and then you can deploy directly from there using the method that Dalen showed, like use the injecting provider so you connect to a wallet, now you're paying to do something on chain, testnet, mainnet. But if you want to learn how to use Remix, there's tons of tutorials. Just go on YouTube, right? There's going to be a 15 to 20 minute walkthrough. You're going to be able to figure out everything you need to know to get started, especially if you have one of those contract templates and pull from OpenZep.
so we can go to BaseScan, which is essentially where we can view all of our transactions. And so ahead of time, what I've done is I've gone to a DEX called Uniswap, and I've essentially swapped my Ethereum for this degen token, which we're going to interact with in a few moments here. So if we look at the transactions here, we can see that about a minute ago we deployed a contract. So what we're going to do here is grab this contract address and start interacting with it. So this contract address is the code here, right? This is what we're going to be interacting with. So this is kind of going to be our interface, and so this is what we're going to be working with. So what we're going to be doing here, I'm going to be importing this address into an env file. Oh, a little bigger here. So importing this address into my env file so I can use it across my application. It's kind of a, plug and play system, right? What I've got here. So I'm updating this env file, and what I'm doing on the React side is I'm just going to be generating a bunch of hooks for it automatically with WAGME. So the key components here are, I'm using Next.js, I'm using WAGME to connect up to my wallet, I'm using Rainbow Kit as a means of connection to my wallet, and I'm using WAGMI CLI as a means to create hooks for all of the functions in my contract on the fly.
Dylan, let's pause there for a second. Let me ask
Yeah.
you some questions about that, just for everybody's benefit. So,
Yeah.
okay, let's say you know that that's your stack. Those are the tools you're going to use to get started. So you've got a Next.js kind of front-end app framework.
Yep.
You've got Rainbow Kit to create a wallet connection button and all of the connective tissue. You've got WAGMI, which is essentially all of your functions that you can use in a JavaScript environment and to be able to interact with this object on a blockchain,
Yep.
right? And then WAGMI CLI, so a component of the WAGMI toolkit, which is going to, instead of you writing each one of those connections and fumbling with it, because like it can honestly take a bunch of time and you can mess that up, it's going to just automatically create right at the top of the docs and says, start a new Next.js project, start a whatever, right?
Exactly, yeah. You can find it on mostly any of those sites. They'll give you a basic template to kind of get all those installed together, and you can go from there.
Yeah, so like as a takeaway, again, if you're just getting started, but you have some familiarity with what you want to do here, you want to use an Open Zeppelin template, you want to use Remix, you want to build a Next.js application. We think the easiest tools are Rainbow Kit, WAGMI, and WAGMI CLI.
Yeah, exactly. So yeah, from there, do we want to stop to maybe ask some questions as we go, or?
Yeah, I mean, this is firing questions whenever you want, but we'll try to pause at a few different junctures. So, okay, so that's a stack. You know, Dalen's going to get into kind of the web side of building this application. Is there anybody who wants to pause here, or you want to just keep going?
Good.
Keep going. Yeah.
Okay. Okay. So what we're going to do here now is, so this contract address, we're going to be copying it and pasting it in a couple spots of our code here. So we're posting it into our WAGMI CLI. This is actually where we're creating all the hooks, and just making sure that we've got it here as well. Okay, so I'm just going to do a quick generate here. This is generating the hooks in the background so that I can use it throughout my app. So what's important here is we're going to look at providers. So this is how we wrap our application with the WAGMI provider, right? With the Rainbow Kit provider, WAGMI is essentially allowing us to connect up to the network, allowing those hooks to run on our website, and then Rainbow Kit is how we're actually connecting to the web to the actual Web3 wallet. Okay, so from there we've got move over to page. Actually, we'll move over to the swap component. Okay, I should probably make this. Okay. So what we've got here is the component that is viewed actually right here. So how we would start off this application is we would sign in. So you can imagine if I am I'm not sure how to disconnect on the Coinbase wallet. Sean, are you aware of how to disconnect on the Coinbase wallet?
No, once you're in permanently.
Okay.
Yeah, no.
All right, we're in. So what we're doing here essentially is we're doing this this create super degen, right? So this is going to be wrapping that degen token that I swapped for earlier on Uniswap, and we're going to be wrapping it into super degen. So we'll go to super degen, or sorry, degen. And so we've got a wallet balance of 90 degen currently, and we can actually view this on Etherscan if we go to our address. Actually, we'll go there in a sec. So what we'll do here is we'll wrap 10 tokens to 0.01. So we'll go ahead and start writing here. And so we can see our output. So we are actually giving up 10 degen, and we're getting 1 super degen. So we will confirm that. Okay, it's cool. So let's go look at that transaction now. Sweet. So we can see here that we have essentially officially wrapped that 10 degen token for 1 super degen token. And so that's half our app right now, right? We can go back here, and then we can go and swap back that super degen token for the degen token. So we'll go through. We'll say this is max. We'll write. We can view our outputs, right? We're doing 1 super degen token for 10 degen token. Confirm that, and we will see our wallet balance update here in a sec. So we've got in 10 tokens of degen and 1 out of super degen. And that's essentially what we've created here. Yeah.
Great. Okay, so again, just checking in, Mike. Any questions? Anything we can be helpful with? We were thinking about this. In all honesty, we found out about this like yesterday. So we did this last night, and then I was talking with the guys beforehand and saying, okay, we should post the code so people can use it as a scaffold. But it's not. We got to clean it up a little bit. So I think if somebody wanted it, and so you've asked for it, the commitment we can make to you is that we can, over the next like 4 or 5 days or something, we can probably clean up that code and put it somewhere so that you can go and grab it. But we don't have it ready today. Okay, so I'm for Project Diamond, what we work on. I started it with these guys, and the team has grown over a number of years. I am easily the worst developer on the team. These guys are all much better than me. So you should use what I use, right? Which is you should use Smart Contract Programmer. Smart Contract, it's just my opinion, right? But like the videos that Smart Contract Programmer does are excellent. They're excellent, and if you use that in conjunction with basic scaffold and like the Open Zeppelin library, you're going to get going pretty quickly. You're going to be able to deploy stuff. You're going to be able to mess around with it and then start to modify the logic. And once you get started, it's the smart contract modifications. The ideas are the harder part, because the logic itself, once you get comfortable in that code base and you see some examples of how other people have implemented it, there's a lot of building blocks that you can pull from. So you'll find you get going really quickly. That's a YouTube channel, and there's a bunch of exercises as well. He's got his own channel, and frankly, I just think he does an excellent job.
You can find a lot of good resources as well through those packages that we're using, right? Rainbow Kit is awesome. You'll find a lot of examples on the WAGMI site. Yeah, also a great resource is if you want to start learning about all this and a whole, like JS and Solidity is actually Alchemy's, we've got like a boot camp. Alchemy University, yeah. Would 100% recommend that.
And just to plug the parent company, Coinbase has been making a really strong effort to put up much more educational tooling too. So there's boot camp for smart contract development up on Coinbase, as well as some style guide stuff that I think the company's been releasing recently, just about how to create that code, how it's how to reuse it and organize it in an efficient way. So there really is lots out there. The biggest, again, as a sort of the least experienced developer on the team, what I find is that you got to pick the right 4 or 5 resources because there's 1,000. And what you don't want to do is waste your time on the lower quality stuff. So I think if you start there and then you kind of branch out into things that help you as you move forward, that's where you're going to get the most benefit.
Okay.
So that's soup to nuts. Now we've got an application deployed. Front end, back end, front end, smart contracts, live on base, costs a couple of bucks to do the whole thing, and well, a few cents to transact, and then you had to have a few dollars worth of tokens, or maybe $1, right? So that's very different. I mean, when we started building the application and the platform that we're now maturing, it was like $1,200 or $1,800 to deploy, even just our first application, right? So on ETHL1, we've really seen a shift, and we started building for layer 2 about 2 years ago, before layer 2s existed, because we knew that we needed that kind of computational intensity to be able to manifest the things that we're trying to build, which are basically real traditional financial instruments and all their logic, and to do that in a smart contract native way. So this is very natural to us, and we're super excited to see the advances on the cost of compute and the opportunity to deploy new things and really kind of just generate activity in the ecosystem. And then being a Coinbase company, we interact with the base team a lot, and the base team has done a great job of just trying to to have a very builder-focused ecosystem. So you want to build something, you have an idea, connect with the base team directly. Their developer support groups are excellent. And they're going to get you going, and they're going to point you in the right direction, and also help you find a community of people that can, nudge you, help you get unstuck, get you moving forward, and also potentially co-founders or collaborators that you can work with as you build things. So the only other thing we wanted to cover today, just as an opportunity, like if there's any other questions or if there's something you're thinking about building, and we can be helpful with just a first reaction or maybe some advice about where to look or projects that might have relevant, useful components, we're happy to do that. We can give you the benefit of whatever experience we have. But otherwise, I think you've got what you need there. And if you want to connect with us afterwards and get our contact information, we can put this up on GitHub so you can use it. Yeah, we can walk around and hang out for a bit. So anybody who wants to talk, yeah, come and hang out. Okay. All right. Thanks all. Thanks very much for your time.
Thank you.
Appreciate it.
think about what comes after or what came before. You just gotta bend your knees, take a deep breath, and jump. And you might think, what if I fall? Well, what if you don't? What if you fly?
Hello, hello. Hello. Yeah. This is higher than this. Okay.
Testing, testing.
Hello. Hello, hello. Are you ready? Yes. Can I start or should I wait something? Wait a bit more. Okay. Yes? Okay. So it's time to start. Can I? I'm good to start? Or you prefer to wait more? Okay. Let's wait 1 or 2 minutes more to have more people. I know that you are here and you are ready. Yes. And I know that's a surprise to you because when we announced the workshop on the website, it's saying only Chainlink. And wow, Chainlink, it's a lot of service. What she will do over there? So surprise, I'm doing CCIP. Hi. But if you need something different as well, maybe I can help you. There are someone here that is in the hackathon. Yes, hackers, I love this. Hackers building projects, amazing. Almost good to start. And if you have your computer, get your computer ready because we are doing some hands-on part as well. And if you know how to copy and paste, you can do this, okay? better if you have MetaMask installed, like it's the only thing that you must have installed before. And especially today, I hope and wish you can wish me like good luck because my computer is dying. Like he died 2 times today. I have a blue screen. I hope this don't happen now. Okay, but if it happen, I will get the Mac. But I'm terrible with a Mac. Let's see if this is working well in the Windows. Okay, now I can start. So let's go. So my name is Solange Gueiros. You can call me Sol. And I am a developer advocate at Chainlink Labs. I teach how to use all the Chainlink services. And I used to go to all the conference to do that. I love to be this in person. And I have with me Ameshi. Could you introduce yourself?
Hello, I'm Amechi. I'm a Chainlink developer expert. I'm assisting Sol today with doing the technical workshop.
Yes, and Ameshi, what is a developer expert? Tell them, please.
So developer expert is a program we have in Chainlink, part of our community that allows the technical ones of you to join, run your own workshops, boot camps, online hackathons, and help essentially grow the Chainlink developer community.
Yes, it is. So if you'd like to help us and be with us in the future, you can be a developer expert as well. And I know that this is the most important slide for you. So if you'd like to have access to this presentation later, I have other links, other information over there. And I know that everyone is like, would like to take pictures, a lot of pictures. If you get this, you have everything. It seems everyone did it. One more over there, 2. Okay, let's go. So, like I told you before, this is a hands-on session, and I'd like to interact with you. So, I'd like you to go to this website. You can type this or take a picture and then go over there, or if you have the presentation, only click on that. Is pad.riseup.net/p/cl ETHDubai. 1 minute more. All good? Can I go forward? I'm going. Yes, take a picture and you can type later. Yeah. I will go over there as well. Let's see. I already have this opened here. And let's go over there. Yes. Welcome, Vilma and Bruno. And I'm here. I'm from São Paulo, Brazil. Oh, we have Pedro from Santa Terezinha de Itaipu. Wow, more Brazilians here. I'm so happy. Yes, and Gideon from Ghana. Wow, Ahmed and Renata. Welcome, welcome everyone. Like you are doing this now, and I'm starting the presentation, and we come back here a bit late, okay? So let's continue. I must both open our time because I will go. So I'm here to talk about Chainlink, and Chainlink, it's Oracle. So what's Oracle? Oracle is the way that you can connect with any information that is outside the blockchain. And can be like codes or data, but also can be temperatures, the information from my watch, or my steps, or sports, or any kind of weather and financial information. So this is the basic, the concept of Oracle. But when we talk about oracles, it's so important that the information comes from a decentralized Oracle network. You used to say that this is a DOM. And why? The way that we have the information inside the blockchain, it means that the input of the information is the most important part, because if you have this information in a wrong way, how can you trust in the blockchain after? It will be hard. So, if you have a decentralized Oracle network, to get a decentralized consensus, you can guarantee to have better information, even if the source is unique. Even if you have a centralized source, you can have more than one node or one person getting the information and guarantee a consensus to retrieve the same information before saving on chain. And this will make the difference when we talk about decentralized oracles. And this is Chainlink. Chainlink is a decentralized oracle platform. We are not a blockchain, we are deployed, we have our services in different blockchains. And we are this, we have different services. And Amesh, could you tell them what is a data feed?
So Chainlink data feeds essentially allows us to bring off-chain data. This can be price data, and we bring that off-chain and we deploy that on-chain. So for example, let's say you want to know what the price of the BTC to USD pair is. We can now provide a data feed using our Oracle network, using paid providers and APIs, aggregate those data and bring that on-chain.
Nice, thank you. And data streams is almost like a data feed, but the data feed is pushed based, like it's updated from time to time, or when the price change some variation. But data streams is pool based. It means that in the moment that you need that price, you get the price in exactly that second. And this is the difference between them. Also, we have VRF, that is to generate random numbers outside the blockchain and use them in blockchain to be sure that this is not manipulated. And Amesh, what's functions?
So Chainlink functions allows you to execute JavaScript code using our decentralized Oracle network. So essentially, your smart contract will trigger a request to our network, and you can have any arbitrary JavaScript code that you want to run. Maybe you want to query a weather API, maybe you want to get sports data. You can add that to your functions code and interact with that directly from your smart contract.
Nice, nice. Also, we have a proof of reserve. This is another kind of data feed where we can prove reserves from some asset, including to get some balance of a bank account and save this information inside the smart contract that you can consume and use in your own smart contract, on your own decentralized application. And Amesh, what's automation?
Chainlink automation, as you can probably describe, allows you to add automation to your smart contracts. So you can set various triggers within your smart contracts, whether it's an event log, maybe you need something similar to a cron job, so on a time basis. And you can trigger that from your smart contract and it will automatically execute.
Yes. So this is an overview, what's the Chainlink platform. And now CCAP, I will go deep on CCAP so we can do this together. I already told you that Chainlink is not a blockchain, but we have our services in different blockchains, many blockchains. And if you'd like to check more about all the services, I recommend you to go to developer portal, because you have use cases, you have the documentation, everything is over there. You already have the QR code of the presentation, so we have everything. And this is, let's talk about CCAP, the Chainlink Cross-Chain Interoperability Protocol. It's important to you to know that a blockchain, it's an isolated network. It means it's an island. We don't have a native way to have communications between the blockchains. And okay, we have some bridges that do this kind of communication, but if you do some researches related to the bridges past year, for example, you can find a lot of hacks. So Chainlink CCAP can be used like a bridge, but it's more than this. And to have a high-level idea what is this, we have the CCIP in the middle, but we have a source blockchain and a destination blockchain. In the source blockchain, you have you that is interacting with some decentralized application. This application is sending some kind of message to the router, and then inside the CCIP part, we have decentralized nodes. We have, in fact, 3 decentralized Oracle networks, we say DOM, 3 different DOMs that take care of this. So they have segregated rules to do that, to guarantee the security part, that is the most important part. And after they do all of this security stuff, we have the router in the other side. The routers are smart contracts that you deliver the message in the other side. The message can, if it's a token, can go directly to your wallet, but if it's another kind of message, must go to another smart contract on the destination blockchain. And what's a message, Amesh?
So a message is essentially what you are sending from one chain to another chain when you're using CCIP. So a message can consist of different fields. So it can have data, so this is just bytes data, and then you can also have tokens, like Solange said, you can send tokens cross-chain, and then you can also include in one message, you can include both tokens and data.
Nice. And this is, I told you that we have the sender that can be you or another smart contract. Also, the receiver is an interesting point because the receiver can be your wallet directly, but every time that you have data, must be a contract with this, the CCIP receiver, because this contract you'll be prepared to receive some information from the CCIP network. And what is the router, Amesh?
So the router is the contract that you will be interacting with whenever you are sending your CCIP message. So every chain has its own router contract, and essentially to send a message, whether you build your own smart contract or whether you interact with the router directly, this contract is responsible for emitting the event that is picked up by the central Oracle network to process your CCIP message.
Amazing. And this, I will pass this and do an overview of the capabilities of the CCIP, and then we are creating smart contracts. So, like I said before, we can do only token transfers, we can do any kind of message like a hello Dubai, and you can do mix this, we can do a programmable token transfer. It means that you can transfer an ERC20 token and then tell what you'd like to do with this token in the other chain. Imagine that you can deposit this token in some place to use it like a collateral, or you'd like to do a swap, or you'd like to do some other transfer or some operation. You can do whatever you'd like to do with your token. And when we talk about messages, the best use of a message can be called a function in the other blockchain, the destination blockchain. We are doing this today, because today we are creating an NFT, then we are minting an NFT from one chain to another chain. This is our goal today, using our computer. And even if I have more slides, I'm going forward for that now. Then I can go back. Let's go. So, your requirements to do that is like to have MetaMask installed, and I will copy this to our pad just now. And sometimes I have problems here, but this is okay. Let's only update that. And be sure that you have everything here. So these are our requirements to have MetaMask. We are using Fuji, so in some minutes we are set up the Fuji. But for now, I have here my personal notes that I'm copying and paste for you. In MetaMask, it's important we are doing this on testnet, so it's important to you to come here and enable the test networks to see Sepolia over there. And if you need the link token as well, I have a special faucet only to us here to use in the workshop. Don't tell outside, please. This is only for workshops. And I know that you need a password for this. This is a secret password to use now, okay? And on this faucet, you can add your wallet and get on Sepolia a bit of it and a bit of link. If you have it, I didn't saw. Let's see. Yeah, it seems that if it's not working, I can add some links here in a few minutes for you. And let's go a bit forward. So if I have my MetaMask installed and everything is okay now, I'm going to remix. So I'm not installing nothing more in my computer. And on Remix, I must have this. I used to have the Solidity, the auto-compile enable, and I will connect my wallet. Let's do that. Here is Remix. It's good for you? It seems yes. So, have auto-compile enable, icon number 4, will help you. Then icon number 5, connect my wallet. So I change the environment to the injected provider. Here we are. This is my wallet, or should be. It seems it's not. Yeah, I must connect this wallet because I'm using another now. Now, yes. So I'm sure that my wallet is connected. Now I'm creating some smart contracts here, and I don't have anymore. I lost all my contracts. Oh, this is terrible. Let's get the contracts again. And I will share this with you because the contracts are here. Okay. The first contract that we are creating will be the cross-chain price. So this is a NFT that is getting the price of Bitcoin in that exactly moment and create an NFT of that price. And the background color depends on each blockchain I am. So I should have a picture of this. Yes, it's this. So this will be our project. We are creating NFTs. The background color is the Circe blockchain. So this will be Ethereum. This will be Avalanche. This was Mumbai, but Mumbai is dead. And we are preparing the other network, so let's do only these two now, okay? And this. In order to create your NFT, let's get the code for you. Cross-chain NFT. And I will add in the pad that can be easy for you. So if I copy this, you can copy what I add here between the beginning and the end, okay? I must do that, so let's do this from 0. This is the code, okay? The name of my file is this. I will be on Remix, create a new file, second icon, and create this, and copy and paste like you. I'm copying directly to be faster. Here we are. Yes, you must trust on me now on my code, but we are learning together, so you can trust. It's only testnet as well. And okay, this is my contract, let's deploy it. And deploy. I came back to the icon number 5, deploying the run transactions. And yes, I have a transaction here to do it. Oh, now I can see that I'm missing over there. Good. So in a minute I have my contract. I'd like to see if you are doing with me. So, if you can add here your name and the address of your NFT, I'll be happy to know if you are doing this with me. Let's see. Mine is here, like deployed contracts, copy, and paste for you. Is someone doing this with me? Let's see. Maybe yes, maybe no. I'm seeing some computers over there. I'd like to see your NFT. Okay, next, if I have my NFT, I can see my NFT on OpenSea as well. So if I came here on testnets OpenSea and search for my NFT address, let's get it again, the NFT address, search on OpenSea. Here we are. We just create this. Yoo-hoo! Is that? The first NFT is always happy because we are starting from 0 to the first price. So I like to be happy, so the NFT start always happy. And this, you can see that was created 1 minute ago. It's real, okay? Now, I'd like to have another blockchain, another chain minting this NFT. Remember that this will be a message, so I must have a receiver contract inside this same blockchain. Let's do this now. How can I do this? I have some mint tests here that I'm not doing now. Now I'm creating a second smart contract that will be this. Oh, let's get my collection for you. If you'd like to see my collection later, is this. And this is so fun because you can see that we have more than 1,200 collections. It means more than this amount of students did the workshops. This is nice. I love this. And let's go forward. So now I'm doing the second contract and I must create that with you as well. So we are here. I must create the destination minter, the contract who will receive the message. And here we are. Let's go to Remix, create a new file again. This is the destination minter. I added for you this, the destination minter. Is this. So we'll have this. You can copy here. But I will copy directly to you here, okay? But it will be easy for you if you'd like to select and copy here. I'm doing the same. And, well, yeah, everything is open now. Here, let's deploy the destination minter. Icon number 5 again. In order to deploy my destination minter, I must pass the parameter that this is my NFT. So copy the NFT address, paste in the deploy parameter, and then deploy. Click on deploy. And are there someone doing with me? Or no? Or I'm alone? Are you following me? How can I know this? It seems that I am alone. Oh. I'm happy when I have people doing it. Yes, you are not doing with me. Okay, you can do later. So let's see what's happened now. This is, I will add all of my contracts here. So if you'd like to use my contracts are public and you can use this as well. So let's get my contract. Here we are. And you have this. Done. So my contract is ready to receive a message and to create an NFT. Let's check it out first. First, I will come back to the NFT to explain a bit more for you. On my NFT has some indicators, some emojis that you define the price. Then I create a chain structure that it's a list of structures. The structure 0 is the Ethereum, Sepolia. The structure number 1 here, no, not here. Yes, here it will be Fuji. So now we have 0 and 1, the 2 is not working anymore, okay? And I'm using the data feed that Amesh explained for you. So I'm getting the price of the Bitcoin in USD and save this inside my NFT. And my emoji is changing based on the prices. If the next time that I mint an NFT, the price went up, I will be happy. If the price went down, I will be sad. Or if the price is the same, I will be like neutral. And this is so interesting because I'm creating this all the NFT on-chain. So I'm creating the image on-chain. This is a different and interesting point as well. And here I will only do a test with my cross-church minter because I will do this test message with you. And what is the test message? This will be the same message that I'm sending from the other blockchain in a few minutes, but I'm sending now here to you understand what I have. So this is the test message where you build SSVG, update, mint, compare price. So this is the price. Oh, I am in the wrong place. I must be here. In the destination, what did the destination do? The destination, first of all, it has this, so if you have a content that you receive a message, you must have this underscore CCAP receive function, and this is using the message inside my content. What will be my message? Like I told you, I have this local, so my message to be this: receive the function mint from an address and the chain. The chain 0 here is what you are doing because this is in the same chain, okay? And if I come back here, you can see that I have the mint from over there. The mint from, do exactly this. I do a safe mint using that chain. And here you can see that I'm updating the metadata and I'm creating all the NFT, the metadata and the SVG live inside the blockchain. And this is the Sepolia part. Now I'm going to Fuji, and if you'd like to follow me, I will add the instructions for you as well. Now I'm going to Fuji and create this another content for you. It will be this, okay? If you don't have Fuji here yet, probably you don't have it, I added the instructions at the beginning. So in order to go to Fuji, I can add this for you down again, because you must go here to go to Fuji. And you can directly connect your wallet and add the Fuji to MetaMask. I already have it, so I'm going here on MetaMask and change to Avalanche Fuji. Here we are, I am on Avalanche Fuji now. So I can create this new content now. If I come back to Remix, you can see, let's create first. Create a new file, not here. Create a new file, now is the cross-source minter. This is the content that you send the mint command to the other blockchain. Now I am in another blockchain. And let's copy it, not the destination, let's copy the source who is sending. And copy to you and for me. For you is here, to be easy for you. And here for me. And here we are. So, in order to deploy this, when I change my network on MetaMask, now you can see here that I'm not on Sepolia anymore. This is Fuji network. And to deploy this content, I must pass the address of my other content that is in Sepolia. So the cross-destination minter, who is on Sepolia, is the content that I'm passing here now in the parameter. This content is ready to receive a message. Let's deploy it, and then I will explain to you as well. And by the way, remember that I created one NFT, so let's see if I have two here now. Two blues, because both was, yes, two blues, and the price didn't change, so it's a neutral face now. And now I have the cross-source minter. And let's have this. I know that you are not doing, I am alone, you are not follow me now. I'm sad because you are not follow me. You could do this with me. Fast? Okay. I think I can go slow. Where are you now? Okay. So I know that because I have only 1 hour, I am a bit fast, but I can go, I can come back a bit. Let's come back a bit. I can, so let's review this. Did you create your NFT? Okay. Did you have Sepolia? Okay, perfect. So if you have the Sepolia, you are here creating your NFT. This is the NFT file, and you copy and paste what is here in the middle of this. Okay. All of this is the NFT until you achieve the end. So here, this is the NFT that you must copy and paste until line 232. And Vilma, you did it. Amazing. And do you have more people creating NFTs? I know that I have 2 over there. They are trying. I'm going forward and then I come back again, okay? I can go to the both places. And so, if I am in the destination blockchain, like I am now, I can use this content to deploy, to mint my NFT in the other blockchain. So how can I do that? Here, I can click mint on Sepolia, but could you explain about the fees? Where I pay fees when I'm doing this kind of things? What's happened to pay the fees?
So when you execute a CCIP transaction, as you know, every blockchain you use has its own native fees, so that's separate. But for CCIP itself, since we're using the Oracle network to process it, you also have to pay an additional fee using Link, and this is paid directly to the nodes that are processing your CCIP transaction.
Nice. So, if you are in the Fuji part, you need Fuji tokens as well. And if you need that, you can get the Fuji tokens in our faucet too. If I came into the faucet, and I know that the faucet seems that didn't have nothing. Let's send something to the faucet to be sure that you can have both of these, okay? Let's see how is on Fuji. Yes, Fuji, I have a lot of AVAX, but I don't have a link. I can send some link to this now. And I'm showing my secret now. I have another wallet, plenty of tokens that I use with the faucet when we need that. But look at, yes, link is here. Let's have some links to you. So I'm adding link in the faucet, okay? Probably in a few minutes, if you came here, yes, you can get a bit of AVAX, a bit of link. I will do the same on Sepolia now, Ethereum Sepolia, to be sure that you have tokens. I may come back to the other network. and send. Again, I'm sending to the faucet 50. It's too much. 10 to the amount of people that we have here. And I must also send, or where is my link token? I don't have the link token here. Ooh. But if I come back to the what I shared with you in the beginning, like here, probably I can use this to add my link token. Okay. So add link token. And you don't need link on Sepolia because it's the destination chain. Like Ameshi told you before, you only need the link on Fuji. But to be sure, I will add a bit now for you in both. You don't need it, it's only if someone would like to get, okay? So let's see if now I have the link to send a bit to the faucet. No, because I am in the wrong place. Let's get the address again. And I'm giving you time to you finish this part and then I come back. Sending a bit of link. 200 again. And who else is minting the NFT? Who minted the NFT? Raise your hand. Oh yes, at least you have more. Are you good now with the NFT? Yep? Okay, let's go for it. So it seems that all the NFTs are good. Remember that we first did the NFT part, then we created the destination minter, the second contract that is ready to receive a message. We start here, we create the NFT, then we are over a bit down. Yes, we have Ia Lambert and Vilma, congrats for you. Now we create the destination minter. This is the contract prepared to receive a CCAP message. And here we are, this is the contract. Yes, Vilma is here as well, amazing. Where are our other friends? Do you need help? Yes, could you, Ameshi or Tyrese, help? We have people that need help. Okay, raise your hand again if you need help. Yes, one over there, yeah, another here. Tyrese, yes, thank you. Yes. Thank you for my friends from Chainlink Labs that are here to help you. This is amazing. And Amon, I think he needs help as well. Yeah. And we have one more. And remember that you only need a link on Avalanche Fuji. So I'm going to Avalanche Fuji now again. Do you need help to add the Avalanche Fuji, or are you good on this part? Good? Okay. Yes. And before I'm waiting our friends a bit, I will explain more things about CCIP, related to CCIP. So where we are now and what we are doing. Come back in here. Yeah? But the workshop also.
When they do it, it says application.
That error application not found used to have happen when we don't have tokens in the faucet. Probably, yeah, the Ethereum has some problem here, but the Fuji it seems to be okay. Yes, some people got on Fuji. You can do the Fuji part. So for the people that, yes, work it, yes. If you have that error, that internal application error in the faucet, try again and get the tokens on Fuji. And for the people that needs help, I will add a place in the pad to you to add your wallet. So I do this in the beginning, like after you did that part. Do you need tokens? So I'd like to know your name, wallet, and what you need. Like, and if it's on Fuji or Sepolia. Okay? And then our friends will try to help you here. Add your name and your wallet here. Yes, like Renata, what you need? Sepolia, okay. I'm helping Renata now. I am on Avax. Let's go to Sepolia to help you. 0.1, it's enough for now. Renata, you should have your token. Where are you, Renata? You should have your token now. Okay, perfect. Amazing. So I will explain a bit more and then I'm going forward. At least a bit. I go to the end and then I come back to help who needs it. Okay? So let's come back here to Avalanche Fuji, and I was going here to show you something. What we did, we start at the end, okay? So we create the destination part. We create an NFT here, and we create this application. This is the destination smart contract. All of this was on Sepolia. Now, on Fuji, we did this part. So this is the minter. Now we are using the minter to mint an NFT that will appear in the other blockchain. So this is the source minter that we are doing now. And the destination minter, in the destination blockchain, we have the NFT and the destination minter prepared to receive the message. Okay? And what I'm doing now? You saw that I created the receiver, and if you didn't create it, and you'd like to use mine, you can. How you can use mine? If you get my address in the pad, oh, now we are good. You have more people here. If you have here that you have the destination minter, now you can mint on Sepolia, but before that, I must have tokens on my contract. I will do this part and then help the people that needs more help. I will do this now. I'm sending 5 links to my contract, okay? Let's get my contract here. Let's see if I'm the right network. Yes. Tokens, link. I am in the wrong account. Let's go to the right account. On that account, I don't have a link. Oh, let's get the link again. Link on Fuji. And now I can send the link to my smart contract and do the transaction. The transaction is do something, I need something like 4 minutes, so I must do the transaction now to finish on time. Like 5 links is too much, but let's do that. Amesh, are you sending tokens to the people? Thank you. So is this, when my contract is confirmed, so now I know that my contract has token. If I came here and get the balance of my contract, add the address of my contract to get the link balance, I have 5. It's more than enough. I will do now the most important part, mint on Sepolia. And remember, I am on Fuji. I clicked mint on Sepolia and confirm this on MetaMask. Confirming. And you can follow me like that. Like always, I add everything to you here. Okay. And I will add my transaction because you can follow my transaction. If you could not do everything, at least you can follow my transaction. This is my transaction. Copy transaction ID, paste here. And I'm checking this transaction now on the CCAP Explorer. Let's go to the CCAP Explorer. And I must get my transaction again and paste in the CCAP Explorer to search it. This is my transaction. Here, you can see that the search is finalized. Did you know about the concept of be finalized in a blockchain? It means that we must have some amount of blocks after the block that our transaction is, to be sure that the blockchain will not have a rework and your transaction will not disappear, like your transaction is really immutable. So this is the search finalized moment. Now it's blessed. The moment that is blessed, it means that all the risk management network approved my transaction. So my transaction is ready to go to the other blockchain. And in a few minutes, this will be ready. Meanwhile, I'd like to go here and explain to you that network that is here. Here is good. So what I have here, remember that I told you that I have 3 different networks that take care of this. We have the segregation of this. So here I did the mint on Sepolia. The risk management network check my transaction. This is the blessed. They approve my transaction. Also, we have the committing done that propose my transaction to appear in the other blockchain. So the commit done propose. The risk management network check if my transaction is good in the CERC blockchain, if it's not manipulated, if it's not a double spend, if you don't have any problem over there. And then the executing done, it's another decentralized network, you execute the transaction. Only after the other networks did their part. And here we are in the destination blockchain. We are not using a token pool because we are not doing token transfers now, but the router already is sending in this moment my transaction to my receiver contract. And talk a bit more about the risk management network. The risk management network is the most important part of CCAP because here we can see if you have, it's a bit small, but if you have repeated messages, or if you have a double spend, or incorrect amounts, or no matching cross-chain messages, like a transaction that is one side and is not the other side, something like that, okay? And this. Probably if I come back now to my CCAP transaction, it's done. Let's see. I hope so. And here you have more information related to the risk management network. This is the most important part. Let's go to the CCAP Explorer. Yippee! We have the success message over there. So let's update my collection. Let's see my NFT. And here we are, we have a red emoji. This red emoji is because it came from the Fuji network. The red background is Fuji, the blue background is Sepolia. It's still flat. It seems that, especially on testnets, we didn't update the price so frequently. So because of this, it's like neutral, but you can see that this was done now. Let's be sure to confirm this with you. So if I came here, you can see that it's minted 3 minutes ago, so all good. And here we are with our cross-chain NFT. I have another workshop that I didn't hear, but the information are in the slides as well. If you'd like to try to use the CCAP to transfer USDC, you can do that in another moment. We have this for you later. And also, I'd like to talk about you this. Okay. We just finished online Chainlink bootcamp. It happened 2 weeks, 2 hours per day. So it was a bit extended. And we started from zero, create your wallet, your first smart contract, and all the chaining services, like create an NRC token using data feed, create an NFT using 3 different services. If you'd like to do it, it's available online, so you can still do it, okay? I know that here it's a faster workshop. I used to do this workshop in 2 hours. When I do in 1 hour, I must run a bit, and I'm sorry if some of you was not with me all time, but we are here. We can help you during all the day, today and tomorrow. And if you are in the hackathon, we can mentor you, and tomorrow I will be seeing the projects, okay? And some people used to ask me how to work at Chainlink Labs. This is the career page, so if you'd like to be with us, feel free to be over there. And remember that all these are in this presentation. Let's share the presentation with you. So if you missed any link, anything that I told you before, this is the presentation. All of the information are there. So I'd like to be sure that you can have this and you can use this later, okay? I think I have time to questions? Probably no. Okay, I have 2 minutes to question. Do you have any question? 1 and 2, yes. No, Amesh is over there. He is doing that. Yes.
So do you have any comments about inter-blockchain communication in your ecosystem?
How what?
Inter-blockchain communication. Like this bridge between networks.
Yes, this is the point that I told you before, that's 3 networks that we have, and they have separated rules in that process in order to don't have any manipulation, and it's like really, really hard to have some attack because we don't have, it's not a node, it's a decentralized network, and it's not one decentralized network, it's 3. So it's really secure to this part, okay? Yeah.
Thank you.
Okay. and Vilma has another.
I was just wondering, to understand better the process of creating the NFT, if you go back to your slide, like where you have this diagram,
Yes.
because it's still hard to understand, like the whole process.
Yes, this. I have embedded that probably this can help you more because we have all the networks. This is good?
Yes.
Yes.
So basically, when we created the second source meter, right?
Yes.
We have to deploy to an address. This
Exactly.
address is, what would be the connection between these two? How can I make
Interesting.
sense?
Yes, like this is the source that this was the last smart contract that we did. This is on Fuji, and we did that pointing to the contract that is in the other blockchain. So the parameter in that moment is the address of the contract that we will receive the message. Was our second smart contract. So remember that I told you that we started at the end. So we started in the destination blockchain, we create the NFT, then we create the smart contract prepared to receive the message and mint the NFT, the receiver. Then with this done, we came to the source and deployed the source blockchain, but in the source blockchain, we already defined that it should communicate with the destination blockchain because we passed the address of that. Right? Nice. Nice question. This is really hard to understand. So I think my time is over. So thank you so much. If you need something, I'm around. Thank you.
Got it. Do you have a mic?
No.
Yeah.
Thanks for your patience. All right, everyone. Thank you for coming, and hello, Dubai. It was a bit of a challenge to get here. I'm not going to lie. I was originally supposed to come in on Wednesday, but there's obviously some disruption in the city. Coming from New York, I know a lot about floods. I did survive Sandy, which was probably not as severe, but then again, yeah, it happened. So glad that we could actually make it. My keyboard's not working. Okay, so this is building on Base. I am Ryan Nitz. I lead DevRel for Base. My background is as a software engineer. I spent the majority of my career working on internet infrastructure. I've been a crypto enthusiast since 2012 and made the full-time journey about 2.5 years ago to work in crypto. You can reach me on Farcaster. Just a quick show of hands, who's on Farcaster? Yes, okay, that's good. That's what I expected at a builder conference. So this is obviously where the majority of the on-chain conversation is happening, and it's exciting to see it's going out everywhere. You can also reach me on X, but please reach me on Farcaster. So for this session, we are going to cover what is Base. We're going to cover what's new. We're going to cover scaling with Base, the path ahead, and building together with Base. So who knows what Base is? Another quick show of hands. All right, there's only about 50%. That's surprising, but that is good. So we will tell you what Base is. So Base is an Ethereum L2. It's built on the OP stack. It's a low-cost network. It's a highly secure network, and it is another quick show of hands. Who knows what an L2 is? Okay, more people. That's good. So a lot of people confuse the side chain with an L2. An L2, the native token is Ethereum. If your native token for gas is not Ethereum, then you are building on a side chain. So Base is an economy. We started with just the developer platform, the network, and we soon realized that what we were building is much larger. We realized that it's a capital market, it's a flow of assets, a flow of value. It's an app ecosystem. It's the apps that you all are building on top of the platform, as well as the core technology. And so if you wanted to make an analogy to another market or another economy, you could look at Apple's App Store. So they have the technology, they have the apps, and they have a path for monetization. What we're not going to do, we're a public permissionless blockchain. We're not going to gate what applications you can deploy on network. Anywhere can deploy an application. We're certainly not going to take 30% of your revenue, and you don't have to have the money to buy an iPhone. So Base is open for everyone to build on. We originally built Base with a vision of a million developers and 1 billion users. That was just our lofty goal that we came up with when we launched Base. And to be frank, we weren't quite sure how Base was going to be received when we first launched it. We were actually concerned that it might be organ rejected. We were concerned that nobody would show up. But people saw what we were trying to build. They saw the intentionality in our messaging and the ethos that we have, and they came and they started building with us. We also then refined the vision into a mission to build a global on-chain economy that increases innovation, creativity, and economic freedom. It's right up there. Let me unpack that a little bit. So economic freedom is so important. There are studies everywhere that showcase that with increased economic freedom, you see longer life expectancy, you see lower infant mortality, you see higher per capita income, you see faster business formation. And with lower economic freedom, you actually see increased war, increased corruption, and you see all the things that you don't want to see increase as economic freedom increases. So our goal is to increase economic freedom so that no matter where you're born, no matter where you're currently living, as long as you have an access to the internet, you can get on chain and you can transact with value with anyone, anywhere, with applications developed by anyone, anywhere. So a lot of people ask us why L2s. Has anybody seen this chart before? This is the scaling mechanism of Ethereum. You can see that for L2s, you can see that blue line is Ethereum. It's basically been flat for the last few years, and that's not by coincidence. Basically, Ethereum is at capacity, and there's not a lot of room for transactions. So about about 4 years ago, we started seeing the first L2s launched. When we launched Base, the scaling factor for Ethereum was about 2x. Right now it's 10x. It'll be 50x by the end of the year, 100x by the end of the year, and it just keeps on growing. We only launched Base about 8 months ago, and you can see how the L2 volume is just exploding. I touched on what Base is. Now I want to touch a little bit on what's new. So Base has been really busy with shipping. We participated in the Canyon and the Delta and the Ecotone upgrades for the Optimism stack and the OP networks. We really cut our teeth on as the first external entity contributing to the OP stack, which is, by the way, for those not familiar, it's a public goods, open source, MIT license. You're able to take anything that's built on the OP stack and use that intellectual property however you see fit. Ecotone was responsible for the implementation of EIP 4844 inside of the OP stack. Who knows what EIP 4844 is? All right, we got most people do. I'm going to dive into how that was impacted, the network and the results of that a little bit later. The Base team also created OPVM and WAGMI. OPVM is just VM is a set of JavaScript and TypeScript libraries that enable simplified development. It's really kind of taken the world by storm in terms of the on-chain ecosystem, and we developed extensions specifically for the OP stack, not just for Base, but for anyone running on OP. That has since been upstreamed into the core of the VM, and we also developed OP WAGMI, which is we're currently working on getting it into the main branch. We launched Sepolia, we improved network resiliency, and we published a ton of learning guides and tutorials in order to help those that are new to the on-chain development, as well as those that have been building for years, actually increase the amount of knowledge that they have in the industry. All right, so we're typically a pretty humble organization, but we've been working really hard. So we just are now starting to highlight what Base has done in the last 8 months. So Base is now, in terms of transaction addresses, Base is now the #1 L2. And you can see Arbitrum is in the light blue, OP mainnet is red, and Base is the dark blue. And you can see that on the right-hand side, we just surpassed Arbitrum in terms of the transacting addresses. Base is also now the #1 platform for L2s for builders. Over the last quarter alone, the number of active developers and builders on Base has gone up about 10x. This is all information on the blockchain. You can actually, if you want to take a look at it, you can see the username. These are all coming from Dune. So you can see the purple line right there. That's Polygon. Polygon's been basically flat, and you can see how Base trajectory is just going up and to the right. Interesting of note, you can actually see that gray line. That's Ethereum. That's the L1. Developers and builders are moving in droves to L2. Nobody wants to pay $15 to mint. Nobody wants to pay $70 for a swap, and nobody wants to deal with the slowness of the L1. The L1, it will be here forever. It provides a core piece of infrastructure for all the L2s. It provides the security layer that is so critical for finality on this. And so we also have our work cut out for us. The gold line at the top, that's Binance's smart chain. And so you can see, though, that's been trending for the last year down and to the right a bit. Base is also now the #1 platform for DEX trading. Base is definitely not a DeFi chain only. We are a very broad chain. There are tons of mints going on. There's tons of social apps. It's now the #1 chain in terms of Farcaster users, in terms of their on-chain activity. And you can just see, though, how the volume of transactions exploded on Base. A lot of this is due to 4844 and the work that we did behind this, and we'll continue. TVL is growing, so we're now at 5.6 billion in TVL. Keep in mind, we don't have a native token and do not plan to issue one. If you take a look at OP mainnet, which is fantastic, 33 billion of that roughly in their TVL is locked into the OP token. And the same is true on Arbitrum. You've got about 4 billion of that TVL. So we expect the Base TVL to keep growing significantly in the coming years. So scaling. All right, 4844 was epic. It drove down fees. It basically became free to do things on on chain. It was a quarter of a cent when it launched, and in order to transfer, and you're talking also fraction of a cent to mint. And you can see what happened. This is our thesis going into this, that if we drive down fees as low as possible, transaction volume is going to spike. And that's exactly what happened. The nice part about Base is since we don't have any tokenomics, we earn revenue from the sequencer fees, and that's plenty to keep the project going. So we can drive fees down as low as possible, and we see economic activity on chain increase, which is a win-win for everyone. It's a win for the users. It's a win for the builders. So that's what happened. And of course, this is also what happened when we drove fees down so low. The transaction volume on the network actually went up massively, and that resulted in huge fee spikes. What happens is that when a network becomes overloaded, congestion pricing kicks in, and then in order to protect the network, it spikes the fees in order to drive down the amount of traffic on the network. So what are we doing to actually remediate this? We're scaling Base. So we're increasing the gas target for the network, and we have a goal of increasing the network by 400x capacity in the next 400 days. We're being very methodical about it. We're being very intentional about it because we don't want to destabilize the network. We also don't want to end up in a situation where you're like having to run a mainframe like on Solana in order to participate as a node on the network. And so we're currently at 2.5 megagas, and we'll get up to 1 gigagas over the course of the scaling of the network. The path ahead. So we are being incredibly intentional about our roadmap. But first, I want to kind of cover the three things that are really laser-like focused on our horizon that are driving our roadmap. The first one is cheap block space, and these are the factors that are actually blocking the next billion users for coming on chain. So cheap block space, you can't be in an area sending 10 cents value and have to pay 1 cent in gas. Nobody wants to pay 10 cents on transactions. Not such a big deal in more developed areas, but we want this to be a global blockchain. So driving down fees, we'll keep doing it. Our North Star is sub-cent transactions, sub-second times. The next one is wallet technology. So the EOAs that we are all dealing with are fine for us. We know how to connect a wallet, we know how to sign a transaction, but give that to your parents and see how they do. My mom would have her passphrase would be a post-it note on her monitor, and then I'd be getting a text every 5 seconds, should I sign this, should I sign this? And that's just not going to be the onboarding experience. And so with wallet technology, we have been really working hard with the industry to promote account abstraction and smart contract wallets. And you're starting to see flows that you've never seen before. You're starting to see Web 2 flows from Privy and from Dynamic and from a host of other partners out there that are crafting these Web 2 onboarding experiences and obfuscating the blockchain so that people don't even know that they're interacting with the blockchain. And this is how we're going to get to 1 billion users on chain. The last part that we see as a major roadblock for mass adoption is identity. And the reason why identity is so important on chain is you cannot get a loan right now on chain. You can do an over-collateralized loan, and that's great, but I can't buy a house with an over-collateralized loan. So until there's strong identity on chain, you're not going to have credit. And until you have credit on chain, you're not going to be able to borrow assets on chain safely and at scale. So with that in mind, we crafted our roadmap in terms of the areas that we're focusing on. And the reason why we're being so intentional about the roadmap is we want to create space for you all to come build with us and to create ways that we can actually help amplify the work that you're doing as long as you're building in parallel. So accelerating decentralization, we want to continue to optimize the governance for the law of chains, the super chain. So working with the Optimism Foundation, as well as the goal is to eventually decentralize Base out of Coinbase completely. Supporting builders and creators everywhere. We have lots of different channels to get in touch with us. We will talk to everyone no matter what you're building. Driving down fees across the board, we covered that with EIP 4.4. making smart contract wallets the default. Coinbase has partnered, as I mentioned, with a number of different organizations and projects, and we're also taking and helping Coinbase actually with their smart contract wallet implementation. Dead simple to on and off ramp. It's not so hard to on and off ramp in developed nations. The UX experience is still pretty terrible, but we also want it to be dead simple to on and off ramp in developing nations around the world. Bringing Coinbase on chain. So Coinbase is fairly crypto forward, but most of it, the operations are pretty centralized and not in a decentralized manner. So what we're doing is the base team is working with 10 different projects going on right now inside of Coinbase. And we're actually going to open source these findings and the things that worked and didn't work in order to help other organizations bring more people on chain. And then making this super chain seamless. This is also related to technology maturation as well as the interoperability between the different networks. So what we're looking for, we also oftentimes get asked, like, what do you want to see built on chain? We are super big supporters of public goods. If you're building something that's open source, that's showing traction, that is actually making it easier for people to build on EVM chains, we're partial to the OP mainnet, but if it's showing traction and helping it make it easier for people to build, we definitely want to talk to you. We are super excited about the unique and fun use cases that are coming out on Base. The number of fun mints, it's no longer these chalice NFTs that are coming out there where people are making investment. It's POAPs, it's events, it's fun things that you want to remember. And we're seeing a massive amount of volume on these. We're not seeing a ton of mints where it's this huge, it's $10,000 to mint. We're seeing a lot of things that are minting for maybe $10 US worth of ETH, but they're actually minting out 10,000 different items. And so we're seeing a lot of traction on that, and people are having fun and engaging on chain. If you're building something that's going to help bring more users on chain, we definitely want to talk. If you're showing impact, we definitely want to talk. One thing that we are super aligned with the Optimism Foundation on is retroactive public goods funding. We are asking for people to come build with us, and if you build with us and you have an impact, you will be rewarded on Base. Part of the core ethos of the Optimism Foundation is impact equals profit. You can actually develop public goods, and you don't have to live like a starving artist. You can actually have a nice life. And lastly, we're providing builder grants. These are 1 to 5 ETH grants that we're providing to non-venture funded companies. If you're trying to actually go out there and make a run at it with your project and you're showing impact and you're showing traction, we will definitely want to talk to you. We're also a part of the super chain, so that gives us access to the retro public goods funding, as I mentioned. And so far, we've given out $45 million worth of retro public goods funding grants. The next round of this is kicking off this fall. It's either September or October, so start taking a look at that. You need to be able to show how you have impact on Base. So put your smart contracts, show that we're super data driven, so show the impact to us. Would love to connect. So Base is the #1 channel on Farcaster. About 200,000 people in there, and it's super lively. People are able to share their projects, get feedback on that, as well as help amplify the work that they're doing. We have a Discord server. There's about 350,000 people there. It's a great place to come in and start networking and start getting engaged with the community. And then we have the Base Twitter channel as well. So thanks everybody for coming out today, and super excited to build with y'all. I'll be here today and also all day tomorrow if you all want to chat. Thank you so much.
Oh, sorry. Just a minute. What is the Wi-Fi? Conference. I would title book.
Okay.
Sorry? Oh. Oh, it's good to go. Hi everyone, I'm Jesh. I work at EigenLayer. I do engineering and DevRel. Today we'll be building our first AVS. It's called Incredible Squaring. Before that, I'll just give a quick brief intro about me. I've been coding for the past 8-9 years, and I've been in crypto for the last 4 years. And this is, this is my first workshop, so bear with me. I previously worked at Solana Labs, Layer 0, and FTX Ventures. And yeah, I think let's get started. So this is a brief about EigenLayer. We have 3 components. One is stakers, operators, AVS developers, and then AVSs. AVS developers are the ones who build AVSs. So for example, they can be like bridges or oracles or anything which requires trust. Operators are people who run these like run the like push data on the oracle or like a bridge, and like provide the computational power. Stakers are the one who give the economic security. And yeah, and AVS consumers are usually like oracles, like lending protocols or like roll-ups, etc. So this is what we'll be building today. It's very simple. First, there is a task generator who will submit a number to be squared, then to the AVS contract. Then the the EigenLayer operators who have opted into AVS will get details of the task. Then they'll send a response. So if the number is 2, they'll submit 4 to the aggregator. And then like aggregator will get info on like which operators have opted into the AVS and then the task. And once that's done, like it will push the aggregated data to the AVS contract. Yes, this is a more broad walkthrough. So it will first send a new task, and then the new task event will be created. Then the operator who have subscribed to it will get it, and then they'll square the number and submit it. Then aggregator will verify the signature, aggregate the signature, and if the quorum threshold is reached, then it will submit it. Yes. Now, before we get our hands dirty, like, do we have any questions? Okay. Does everyone have Docker installed? Can I just get hands up, like who has Docker? Okay, very few people. So yeah, let's just take 5 minutes to get Docker and the other prerequisites installed. So head over to Incredible Squaring AVS on GitHub, and over there is does everyone have Foundry and Zap pretty installed? Guess not. Yeah, let's actually start with Foundry. So go to Incredible Squaring AVS, and the commands are over there. Like just copy it and paste it on your command prompt. Well, we have Foundry installed now, and I already installed Zapretty. Is everyone on the same page right now? Oh, can I get a yes or no? Or just a hands up? Okay, awesome. Okay, well, next steps would be to download Docker. Just head over to docker.com and download Docker desktop for your machine. Okay. We'll take 5 minutes off for this to download Docker and Foundry. Yeah. Yep, time's up. I believe everyone got their Foundry and Docker installed. Next, go to Incredible Squaring Avius on GitHub and copy copy the link, and let's clone it. Okay, cool. The squaring, and next we're going to compile all the compile and build all the smart contracts. So let's do that. Meantime, we can go over the other parts. So next we'll be deploying all the required stuff, and running an Anvil chain with and get all the EigenLayer and AVS contracts deployed. Next we'll run the aggregator and the operator. And once this whole thing is done, we can go through all the service managers, task manager, other contracts. Yeah. Awesome. We have everything compiled now, and we can go and deploy all the stuff. So right now we have a local chain running, and we have got some transactions here, and yeah. Open a new tab now, and let's run the aggregator and operator. So this command basically registers the operator on EigenLayer and then deposits like about like 1,000 tokens in the strategy, and registers to the AVS registry. And yes, now you can see that the aggregator sends numbers, and the operator. Oh yeah, sure. fine. Yeah, so as you can see, the aggregator sends numbers to, posts the numbers, and then the operator squares it and sends it back, and it's all happening on the chain. Now, during the whole process, does anyone have any questions or, oh yeah. Sorry? Oh, larger? Okay. Awesome. Does anyone have any questions or has any roadblocker during the whole thing? Yeah. Oh, right now, so we deployed so the question is, what's happening right now? Yeah, sure. So let me just get back to the graph here. Sorry. So the question was what's happening right now. So basically the task generator is sending numbers. So if you can see, wait. So here, right now the task generator is the aggregator, so it sent a new task, so number 15 to be squared. And after that, the operators which have opted into this are receiving the task, and they're squaring the number and sending it to the aggregator again. Here, so if you can see here, the aggregator received signed task response. So this is the response here, and after that, the threshold is reached. And once threshold is reached, it sends the data to on-chain. Yep. Does it answer your question? Awesome. Do we have any other questions? I guess not. So we can dive into the contracts now. Cool. I'll just terminate this now. Is this visible? Awesome. Let me just get back here. Yeah. So there are 3 contacts. One is the service manager, which will eventually contain like slashing logic and like once right now it's just a placeholder. Second is task manager, which creates which contains task creation and response, and then there is the registry contracts. Yeah, let me get back to this. So this service manager will contain slashing logic later once we have it. And now the task manager. So here in like this is where like the task generator creates the task. So like in this case, like it gives the number to be squared and quorum threshold, and like also the byte data. And inside, like it creates the struct and creates the event of new task generated, and Yes. After that, we have respond to task. So this is where the aggregator aggregates everything and publishes the task response. And yeah, this is what the logic looks like. And like if they have any, if there's any challenges, so like in case the number is not really the square, so like if the number is 2 and like they submit 4 and the aggregator aggregates and publishes it, like someone can challenge this and then they resolve it. So this will be, we'll have more data about this, more stuff on this like once our slashing logic is, slashing is live. Yes, with this, like, does anyone have any questions for now? Sorry? Yeah, this is.
Starting point is here. New task.
Sorry,
right?
can you
Starting point.
Yeah, this is the logic. So this is where all the so like if this is where all the main service logic exists. So like the squaring and everything is in this one, this contract. Then the other slashing logic and slashing logic will be here in the service manager. Yeah. Does anyone else have a question? Was anyone able to like run the demo on their machines right now? Just raise your hands if yes. Awesome. Cool. This is what like right now it looks like. This is actually a we have like more stuff coming on, so we'll have reference architectures and more stuff on this like coming up like in the next 2 months, and we'll have payments and slashing coming up in the next 6 months. Yeah. If you have and if you want to like deep get in this more, get deep into this, then you can go to docs.eigenlayer.xyz or bit.ly/learn/el. This is where like all Nader has created all the like dumped all the resources for like getting into EigenLayer. If you have any questions, you can also message me on Telegram, Twitter, or like email me. Yes, right now there's a hackathon happening. And Code Club is organizing their own community hackathon for EigenLayer, for building on top of EigenLayer. And yeah, that's the link, bit.ly/el/hackathon. Yep. Does anyone have any questions right now? Okay. I think that's a wrap. This is the app. I may need to start open the. Yeah, just a minute. Oh, it's actually open. Yeah, you can scan this and get a app right now. It's a cute elephant and an infinite symbol. Sorry? Oh, wait. Yeah, sorry. It's starting in 3 minutes. Let me actually open it. Wait. Yeah, but I think it would be good to go now. I can try it again. Awesome. Yes. Thanks for joining. Thanks for listening to the whole talk. If you have any questions, feel free to send it to me. And yeah, thanks for having me.
Hi guys, we have about a little bit of a break before our next session. So our next session is scheduled to start at 4:30.
Hello, hello, guys. Take your seat. We will start in a few minutes. Okay, hello, hello, sirs. Let's start. Can you show my slides? So shortly about me and what we are talking today. I have a talk related to continuous delivery because this topic is not really covered well. And if you decide to launch your own protocol, if you really want to real hurdles and problems which you can face when you manage it, it's really my personal experience and experience of all our team members which continuously build a pretty complex stuff. So basically, why I'm talking today about these things. The first part, today, luckily, Gearbox achieved 400 million TVL. Yeah, it's great. Yes, thank you for congratulations. But still, it's a huge responsibility. And Gearbox itself based on many integrations. So me personally know how painful the world DeFi composability. And even if you believe that all tokens work the same and so on, I have a some bad news for you. It's not true. We list around 70 tokens and we really deploy V3 maybe in December of 2023. And then it looks like each week we add 2 or 3 tokens. So it's a process. And if you manage a DeFi protocol, you should have processes. Of course, all this stuff comes from the DAO through the voting. And in this speech, I want to talk how we can really make it in a safe way, not to make a mistake which could cost a lot of money. If you know, there is one protocol when people make a small typo in their deploy script. They change LC, and then it was a liquidations up to 24 million. Unfortunately, we could not share our experience, but I can talk what we do to prevent such things. And another part which is very interesting, that Gearbox itself is driven by DAO. So all stuff done by people who are decentralized. We manage the protocol through the votings. We openly for all stuff. And I believe it's like a crypto vibe that we shouldn't have something hidden. We have no additional tooling in Gearbox which help us to get more information than other DAOs members do. So basically, it's a quiet way how we can do. A brief explanation what Gearbox is. Gearbox, it's a leverage solution. So basically, you can get up to X20 leverage for really any coin you want. So basically, we work with different assets. And now, do you believe what is the most demanded tokens at the moment for leverage? No, it's USD, it's your borrow, but what you are using for strategies? Yeah, it's different risk taking tokens, correct. because it's a point money and another part related to Ezina. So in Gearbox, it's a quite unique solution when you can in one click open a position like X10 in REST staking token or in Ezina token and get a lot of points. And I've heard a really great numbers of people who do that and really become rich. So our point is to add as many new protocols and integrations as we can, because people really like leverage, especially during the bull market when everything is grow. And a short recap related how it works. So here you can see our architecture. Gearbox is two-side protocol, and I will just highlight the things which is significant to understand. The first part, there are two sides. One is the passive lenders. These people just provide money similar like you can deposit them in the bank. Currently it's around 50% APY in stable coins and around 25 for ETH, which is pretty impressive. And this part, you just provide money and forget it all about that. They just brings your yield and you can take them at any time. When you talk about the right side, this is ninjas, warriors who take the leverage to make more money. It's a pretty impressive guys who know how DeFi works, they know how to make money. And what they do, what's the innovation under the Gearbox, it's a credit account. So each time, if you want to get a leverage, you provide initial funds, for example, 1/10 of desired amount. Then this credit account is an isolated smart contract which behaves like smart contract wallet. Immediately take a margin loan from the pool, and then you can interact with third-party protocols on behalf of this credit account. So you simply send transaction in a multi-call, and that's all. Basically, it's a pretty simple to explain. If you want to long ETH, you borrow USDC, and then you swap USDC into ETH on Uniswap. And it's all. Yeah? So you keep ETH, it's a collateral, you cannot withdraw it from credit account. At the same time, you have a long position. Then you take this ETH and put into restaking, and now you long ETH, but in restaking form and get more points, and so on and so on. So pretty simple. And here as step by step. So on the first step, borrower provide 10 ETH and borrow 91. So as a result, you have 100 ETH on a credit account. And then each transaction going through a special security check. So basically you can send everything, but Gearbox itself, we use whitelisted contracts with which you can interact. And here you can see only part of them now, much more. And then after each interactions, when your credit account, you just manage your credit account, we compute that the health factor is more than 1, which means that there are enough money to pay the debt back. As I said, you can interact primarily with any protocol, which makes Gearbox very, very flexible. And Gearbox is a modular, and here I want to talk about the complexity we have already built. So basically, as you can see, the protocol, because we should really know how to compute each asset value connected with different oracles. So now we use Chainlink, we use Redstone, we use Pool Oracle Redstone, which is updated by users, and we use some our oracles which based on contracts value to evaluate the curve LP or different LP tokens. We have adapters which help us to interact with third-party protocols. Each time when you interact with Uniswap or Curve and so on, all transactions go through them and they create needed approvals to make a really great experience, because in Gearbox you shouldn't wait like approve, then make a transaction, then approve, then make a transaction. Everything done automatically, and in one multi-call you can build any strategy. We have a router, it's like 1-inch analog, I think so, to make it possible to find on routes, because 1 year ago we faced the problem that there is no ready-made solution to find a way from USDC to a complex convex position or so. So we built this router, it's another piece of infrastructure. Of course, there are some liquidators who manage by third party, some front end which also consume this router. So many parts, and of course governance which really updates the protocol. And we have so many different moving parts. And my talk today is to explain how we really solve the complexity. And the first topic, which is really fun, that composability as a nightmare. because nobody knows that ERC20 tokens, it's a only interface. So everything could be inside. You couldn't really list any token. There are some security issues. You can check them. But then, of course, each token has its own implementation. For example, if you know DAI on mainnet has its own permit signature. So on your application, you should definitely have two parts of code, one which could monitoring works continuously, and it really helps us to find some edge cases what is really beneficial. Related to the governance risk, a gearbox managed by multi-sig, so we also have a full control. We got immediately notification when someone create transactions, sign it, or execute, just to really know what happens. In gearbox, multi-sig is limited with 36 hours, so it's a very, very significant to have a time to make a beta transaction if some malicious could get an access or add something or so on, because we should keep hand on a pulse. So what we do, we also check all the contracts deployed and how it interact. And basically the whole information which comes from different systems like protocol monitoring, DNS checker, it's another system we continuously check that DNS records was not changed. It was hacked in the Curve protocol when someone could bribe the, I forgot the company, and change the DNS to point to malicious website. Now we have a robot which continuously checks the DNS. If the change happens, we also got notification. We also use the aggregatex to check and compare different prices, because of course, if we can find some huge deviation on Binance to prices we can get from Oracle, it's also another thing we should understand that something goes wrong. And of course, some stuff related to standard Grafana, which also help us to understand that all services are healthy and working. And another part related to monitoring is how to make updates. As I said, and previously, can we show this picture? It's how we really start deploying. So basically, as you can see, this fast growing was possible because we were able to really launch a few tokens per week. It's a pretty hard process when each week you should make the whole cycle from idea, hey, we want to really add the token like Renzo is, to make it possible and check that all systems in Gearbox work properly, and when this transaction will come to the mainnet, they will work properly and nothing was broken. And here, how we achieve that. The first part, let's talk a little bit about how the governance process works. After snapshot voting, the transaction comes to multi-sig, then it's going through 36 hours, and then the protocol is updated. For something, some really emergency thing or things which could be updated a little bit faster, which do not have a huge impact to the protocol, we have a special smart contract which is called controller time lock. It helps, for example, to update some risk parameters in value. So basically, DAO could make a permission to change liquidation threshold not more than 10%. So sometimes controller time lock could make these changes. And for good updates, we use this schema. At first part, we have some hypotheses or ideas what we should add. Then we build a script, and then we use our own development, which is called cloud testnets. And cloud testnets, it's a good way when we can really make a new network and everybody could connect it to it to check all services after this update. As I said, we should check front end, we should check liquidators, we should check different data analytic platforms like Defilama and so on, and be ensured that on the date of update, everything will continue work as it designed. And then, of course, it's going through the voting and time lock and protocol, what I mentioned. The first part, I believe it's a very crucial thing, is to make logs in more human readable way. When you work with thousands of addresses, it's pretty hard to understand what happens and what each transaction means. So basically we have like our own standard, which definitely explain what's going on, which contracts are deployed. It's just a screenshot with which parameters are set and so on, because to manage all this stuff when deployed, sometimes it was like 100 transactions. It's pretty hard to understand which address related to the thing. And another part, what we already built, each time when you make a push into GitHub repo, we have a cloud testnet platform, and here you can see there are active forks. So each time when I make a commit or anyone else, we have a special fork which automatically starts on CI, and then it deploys everything to make a new endpoint, and then people who can launch test, launch liquidation test, and test front end could use this endpoint and get all information about new updated state. So basically, if you click on any part, you can find a lot of information here. This is the fork for GIP 117. I think now it's under the voting. And here you can see a lot of good stuff. So basically, you can find endpoint, you can find different logs related how optimistic liquidation works. You can find information how state was updated, how all tests related to the current deployment works, and so on. And this system was built as a cloud system on AWS. And what is really interesting, for each network, we have our own copy of RE's node, because, as I said, when you work with multiple protocols, currently it could be like up to 20 protocols connected. Each protocol has its own state, tokens, balances, and so on. Like running Anvil using normal RPC could be very, very long time process. It could take up to an hour, and it totally breaks the whole development, so you should wait so long. To solve this problem, we have a RE's node which automatically sync with currently state. For example, on mainnet now it's state around 2 terabytes, but it helps us to make queries pretty well. As you know, RE's node itself could not really provide a pretty fast querying for events. If you try to run your own RE's nodes and run Anvil upon it, you could not really get queries pretty fast. To solve this problem, we have a special our software which is called Anvil Manager, which really reroute all events query like get logs to normal alchemy. And in this case, we can really achieve two things. For state changes, we can check RE's node. For all events, we use RPC provider, and it's create a very, very fast thing. So basically, in comparison with normal RPC, maybe it's 20 times faster than it exists. Then another part, what is also significant, all oracles which exist on your simulated network has a time when the prices become stale. And to solve this problem, we have a special server which continuously takes the Oracle transaction, like Chainlink updates and so on, from normal mainnet and bring it to our testnet. So in our testnet, for a whole day, we have updated all transactions which do not break the system, because of course in Gearbox we control that the price is not stale, and it's a very significant. Here we continuously deliver transaction to our testnet to make it possible for at least 24 hours to work with current market state and check all these liquidations and so on. And of course we have some filter which do not allow from external part to make any changes using Anvil cheat codes and so on. So basically it's what I really want to tell, two big parts. The first one is a cloud testnet software which could really help to make any simulation at the moment. I believe it's a very crucial if you want to test any composable protocol, because composability, it's a really nightmare and painful things. All time you should go deeper and find all cases. And if now you can definitely check and simulate all possible cases related to some emergency things like liquidations, pause events, and so on a testnet, it's a good stuff. The next part is related that very, very significant to have all monitoring and use them across all time, especially when you deploy or update the system to get the fresh data that everything works correctly or not. So it's what we use, and it's how we were able to really update the protocol and add more tokens and protocols each week to achieve this 400 million TVL. So basically it's what I want to talk today. If you have any questions, please. Already. Okay? Thank you guys for attention. Thanks for your time. If you have any question, you can ask me privately here. I am here on the conference.
Next workshop is at 5:30. Next workshop is at 5:30.
Okay.
A lot of people very interested in this workshop. Like, yeah, okay. Anyway, I need to do it. Hey guys, I think we can begin. So I will start with a short introduction. Fathom, what we are doing, and basically about us. It's about agenda. So basically we are building DeFi ecosystem on XDC network. Right now we have stablecoin, lending, vaults, DEX, governance, staking, already deployed and released on production on XDC network. And we continue building and releasing new products. So we just released lending, and like more new stuff is coming. So like about our principles, so we believe in liquidity, and our like main goal in the nearest future is bringing RWA assets to the XDC network. So very soon we are planning to introduce Contact Gold on our lending protocol, and I believe there will be more in this like nearest future till the end of the year for sure. And we make it like available to the people and to the community. So what we have right now, it's like first of all stablecoin. It was released last December, and we have already like in total in protocol we have like LTV around 7 mils, which is I think is good enough. And so we have stablecoin, which has right now only one pool, XDC pool, and it's FXD stablecoin. If you are familiar with MakerDAI, you're basically familiar with our FXD, or I mean, it's pretty similar. It's a crypto-collateralized stablecoin protocol with over-collateralization, softly pegged to US dollars. Also have lending protocol. It's our fork. So if you're familiar with our, you're also familiar with our lending protocol. DEX is like Uniswap v2. So basically all this you see in this picture was already released and available on production networks. So feel free to try it. I'll show today how. So a bit in details about like our stablecoin protocol. It's very similar to MakerDAI, as I already mentioned. First of all, it's all collateralized, so amount of collateral locked in protocol is always greater than the amount of stablecoin issued, and which allows us to keep the price. But like if you're talking about mechanisms how to keep price pegged, we have stable swap, which allows whitelisted wallets to swap USDT and our FXD in a 1-to-1 ratio, and it allows like natural arbitrage process, so people can just swap tokens, get a profit if price valid. As I mentioned, right now we have XDC pool, so you can use XDC. It's a native token on an XDC network user collateral, but soon we'll bring more tokens, starting with Contact Gold and some other like RWA collaterals. Okay. Okay, we have a Fathom DAO. All what is happening in our protocol, all changes, they go through the proposals and voting system. to get some WoW token, you need to have our like FTHM governance token first and have it locked in stake mechanism, which gives you voting power, and you can use it to create proposal and vote for proposals. Okay, let's go to some more technical demo. Okay. So, first of all, our protocol is deployed on XDC network, and of course, XDC testnet Opossum. So, where it starts? Okay, if you want to use Opossum, first thing you want to do is go to some faucet. So you can see here like faucet Opossum network, and here comes some tricky things. So, okay. If you want to get some test tokens, you need to be sure that you use correct prefixes, because unlike other EVM compatible chains, you have some very specific prefixes, XDC instead of 0x. It's not really impacts work of the protocols itself. For like Solidity code or writing protocols, deployment scripts, you can use normal addresses. It works with it as well. But in some places, you should expect like addresses with XDC prefix, which is fine. Also, I want to mention, if you're working with mainnet XDC, you want to connect it with some other chains, you know, send money in and out. There is, okay, I don't have it opened, one chain XDC bridge. I have it open here, I believe. Yeah. So there is one bridge that allows you, like say, send money to and out from XDC network, so you can play around. About XDC network itself, it's very cheap. Transaction costs basically nothing, almost for free. So you shouldn't worry about it. It's very fast, scalable, has huge transaction speed, so it works very smoothly. If you want to find some RPC nodes, you just can use chain list, and you will get a list of available RPC nodes you can use to interact with Opossum or XDC mainnet chain, which is very handy. So no problem with this. Yeah, you can check our GitHub. We have some handy SDKs. I will start with integration with our stablecoin protocol. So we have it's our GitHub. Yeah, we have Fathom Solidity SDK, which contains all the interfaces needed to integrate with our stablecoin protocol, FXD. And I'll show you how to use it today. So I already prepared some code in Remix. Basically, all the interactions with our stablecoin protocol goes through a proxy wallet created. And this proxy wallet is owner of all the position. So let's take a closer look. You can find this code in the repository, our GitHub, Fathom Solidity SDK repository, without changes. And here you can also find some contract addresses for testnet and production. Okay. Let's deploy some contracts. So here we we'll deploy this proxy wallet owner contract. Oh, sorry. Okay. I have some transaction, but somehow it's not shown here. Okay, let's go to Possum block scan. We'll check the transaction. Oh, it's success. Yeah, contract created. As you can see here, you can find some mix of prefixes, XDC and 0x, but it supports both. Just things that needs to be kept in mind. Okay. So yeah, we have our contract created. First thing we need to do is create our proxy wallet. It's basically gateway. We interact with our protocol. So you can skip this part with this contract I just deployed and do it manually, but you still need to create a proxy wallet to interact with the protocol. So we can see that it was created. Let's try open some position. We'll send some, let's say 100 XDC. This will be our collateral. And at the same time, we'll borrow, let's say 10 FXD. Okay, we have some transaction failed. I wonder why. Ah, okay. Oh, yeah, that's unusual. That's very weird. Let me try and replace this contract. Check it once again. That behaves very strange. Okay, contract. Okay, here we have our proxy wallet. So let's try to borrow some money. Okay, let me try to change your PC. Okay, so it was just an RPC problem. To be fair, it happens sometimes. And not in the best time, for sure. But yeah, here we have some transactions successful. Let's check it in a block scan. So we can see some token transfers. Deposited 100 XDC, which was wrapped under the hood, and got one FXD. So we can see logs, transfers. Let's check further. So, boom. So our contract. Yes, this is our deployed contract. Let's check it balance. I think. This is our stablecoin contract. Okay, it's probably transferred. Okay, I believe it was transferred to the owner. I can transfer it. Yeah. So those tokens were transferred to the owner of the contract. Yeah. Right. So yeah, in these simple steps we were able to create a position, deposit some XDC, and borrowed one FXD, which I would say was smooth except for the some RPC error, which is not very pleasant, but okay. We have what we have. So we can check out that information about our positions. Let's try to close this. Basically, okay, I believe we need to approve the contract first. Let's try to repay. Okay. Yeah. Sorry? Now let's try to close the position. Okay. Transfer some money on contract. Still not working. Any idea? Okay, makes sense. Oh, yeah, wrong position AD. So let's check our transaction. So yeah, here you can see that we paid one FXD and got back our like 100 XDC. So yeah, maybe with some small issues, but still we were able to open and close position, borrow money from the protocol. Okay, let me show you our UI as well. How to work like so. From UI perspective, it's very simple. I will show you on the production network. You just need to. You can use MetaMask Wallet Connect to interact with our protocol. So I already have some small position opened for 2FXD. Let me show. Like you can top up position if you see that it can go under the water because of XDC price violation, price drop or something. You can repay it partially or fully. So let's. Okay, I don't have enough FXD. Okay, let's do the other trick. So I'll show you landing. This is our landing page. So you can use much more assets here for as a collateral. Like you can use USDT, XDC, FXD, and borrow these tokens. So I'll show you like from how to interact with this from UI. So let's say I want to. I'm using wrong. I do have that. Oh, okay. I basically need wrapped XDC at this point. Okay, let's go to DEX and wrap some, say, 100 XDC. Successful. So let's go to lending, supply some more, approve it with signature, introduction. Okay. Yeah, and we can supply it. So at the same time, let me borrow some, I don't know, let's see, the FXD on the landing. Very simple, very understandable process. So from the landing perspective, you can see your supplies, your borrows, health factor, and you can find some market values about like total supply PY for the tokens we have in the pool, and about your transactions. So now I do have some FXD balance. Let's try to close the position from the UI. So let's try repay one FXD first, so we can partially repay it. So, yeah. Now we can see that only one FXD borrowed, and we can go repay this position entirely and close it. So, yeah, now we don't have any position on our FXD, but let's make one. Let's put some, let's say 200 XDC, and we can borrow max of 4.36174, but it's too much in any like price changes. We can get our position liquidated by bot, so let's borrow, let's say 2.5. Yeah, so as you can see, all these like parts working together and provide you your favorite way to borrow and supply tokens and increase your like possibilities in creating liquidity using all the functionality of DeFi ecosystem. I already showed you DEX. We also have vaults, so basically you can deposit your tokens, case FXD, and expect some like income from it. It like can have different strategies. So far we have only one FXD strategy, 3 months, so you can supply your tokens. It's kind of like Yarn protocol if you're familiar with it. It's pretty much similar. Okay, do you have any questions so far? Okay, let me show you some other stuff then. So, in terms of integration, sorry? Yeah, So you now, if you want to integrate with our protocols, there is this Solidity SDK, as I already mentioned. It allows you to integrate with FXD. Also, we have SDK for client, from client side, so you can check it out in our repository as well. Yeah. So if you're familiar with Aave protocol and Aave flash loans, Aave Lending is fork of Aave and supports the same functionality exact. So yeah, you can perform flash loans for all the tokens in supply, but right now on the prod environment, flash loans are disabled for the period of time while we get some liquidity. So until liquidity is relatively small on our markets on lending, it's disabled. But I think we will enable it in a month or two, as soon as we will get some liquidity. I prepared some links. Okay, let me do it that way. So guys, you can scan this QR code. It's a group in Telegram. I already shared the link in this group, and you can message me in this group and ask any questions you have regarding the Fathom protocol. So it's like set up for our communication. Oh, yeah. Now it should be visible. Cool. So you can find some information, some like all the useful links, so including white paper. So white paper basically contains, I believe, all the information you want to have regarding our protocol, and we will continue adding more with all the launches we are doing right now. So we have like stablecoin details, DAO, DEX. I believe right now we don't have lending documentation here, but it will be added soon because we released our lending basically this month. It's very brand fresh new. But as I mentioned, it's a fork of Aave, so you can feel free to use our documentation. We don't have any like breaking changes. except for some probably naming, and that's pretty much it. Yeah, all the smart contracts audited, we are mostly working with Oxorio, our company. I believe there should be some links on audit those on the, yeah, so you can see like FXD audit report, for example, and some other reports as well. So yeah, all the smart contracts audited, tested. We're doing our best to be sure that upgradable functionality. Yes, for sure. All the like protocols are upgradable. Yeah, I mean, definitely. Yes. Any other questions so far? It's definitely possible, but like so far we have only one strategy on from the world side. But more new strategies would be introduced in the nearest future. So you will have like some list of the available strategies, and you will be able to choose which one is most suitable for you. Thank you. I think we can end, yeah, from here. Thank you.
Hello.
Ну, давай.
Габа, посмотри, пожалуйста. Да. И там можно контрастность повысить, чтобы экран не белый стал, а такой типа потемнее. Вот там солнышко есть возле фокусировки, его вниз надо. Да. Да, типа я рассказываю, там типа что-то. И реально микрофон включен, прикол. А если я крикну член там или еще что-нибудь?
Вот. В общем, выходим с Дагамой, разъебем этот рынок, ребята. Пока никто не слышит, можно говорить все, что я хочу, правильно? Так что как-то так. Всем спасибо за то, что пришли, скачивайте наше приложение и так далее.
So